speech. And what he said in that speech was, we have to build back better.
Yes.
At which point Joe Biden called and said, you stole my line.
Hey.
My inauguration speech. And Justin Trudeau said, well, I only steal from the best.
Right.
And somewhere FDR's descendants are saying, wait, what about me? You took it from me. It's gorgeous here, but it was pouring rain today. Really, the skies opened up. There were wonderful thunderstorm clouds just all over, and now it seems to be lightening up. So I'm hoping I can take some pictures over the next couple of nights and see some northern constellations with some actual depth. I don't get to do that in Montreal.
But Kareem, be very careful. Do not fall off that your balcony there, because it looks like it's a long way down.
Have I ever told you the story of when I fell off of a second floor balcony right before a debate and walked in, still did the debate, and walked out, and half the people there don't remember me saying anything because they were just in awe that I walked back in and kept going.
Yeah, right.
I hadn't heard that, Kareem.
I'll tell you the full story sometime. It was a very bizarre weekend.
That's awesome.
Conal, how you doing?
Wonderful. How are you?
Good. Are you ready? You're presenting at the Alcon, right, this year?
Yes, that's right. Just in August, the 21st or the 22nd. We're trying to nail down a date right now. I start classes at Penn State the 23rd, so
Good for you.
I got to figure out the schedule first, but I'm very excited about it.
So I grew up in Southern Pennsylvania. I'm so happy to hear a fellow Nittany Lion is coming in. That's awesome.
Really?
Yeah, I didn't get to go to school there, but I got to visit often.
Everybody talks about it. Everybody says they love it. They say your blood runs blue or something like that.
Yeah, your blood runs blue, but I'll tell you, their physics and their astronomy and astrophysics is fantastic. The profs are so open to explaining, and all they want is questions to be asked, and they're more than open to chatting. It's fantastic.
That sounds wonderful.
Hey,
I'm looking at doing the astronomy club there and make some things happen. I was reading their website. I think they make some of their own mirrors. They said they had an 8 and 2 10-inch Dobsonians they made. And then the astrophysics department has a 24-inch plane wave that they use for all kinds of stuff like photometry.
That's gorgeous. Oh. And I think it was Enrique Gomez who was saying that the Appalachian Song project, they had a couple of people from the Poconos area that were participating in taking photometry curves for them. So I don't know if that's with Penn State or not, but you could always look to get involved with some of those interregional groups.
Mm-hmm.
I went to summer camp one summer in the Poconos.
Oh, fantastic. And you were up in the Catskills all the time, right, David?
No, 3 summers in the Adirondacks and then 1 in the Poconos. And then back for another 3 summers in the Adirondacks.
Oh, nice.
Hi.
Hey,
Hi, everyone. Good evening.
Oh,
everyone.
How are you?
Fine.
So are you guys ready for some, you guys have an amazing group. You got I found some amazing videos about comets that's going to be in this program, all through the program. So it's going to be a lot of fun.
Yeah, absolutely. It's a pleasure today listen to David Levy talking about, come on, their own comet.
Yes.
For me, I am amazed because it's every week I am amazed, listen the poetry, but today is, come on, it's like, wow. I'm really excited to listen tonight and talk about this. David, you're my hero.
Well, I thank you. Except it's going to be more of a discussion. When Scotty and I were planning this, I kind of wanted it to be more discussion so that more people could participate.
Yeah, yes, of course. we will talk all that week. For me, I can all that I remember from that comet, especially was the I think that was the first, not only of course the first time that people can take in the history. I think that never in any observatory, professional observatory, can take a picture of an image of impact of a comet over Jupiter, but was the first time that the people, amateur astronomers, can do it too. Was together, because was in a time where the planetary cameras starting to be able to take this type of pictures. For me, it was amazing when I started to see the amateur, my customers. I say, okay, I see it. I have the image, and was so strong that, come on, the scale of the impact. Yeah.
What was so wonderful about it, Cesar, is that, you know, all the experts were telling us we were not going to see anything, you know, and there we, you know, and then we saw the aftermath of the impacts, the scarring that was across Jupiter, you know, and I took to my home, because I was working at Meade at the time. We had bought a Tasco 50 millimeter refractor that we were just keeping in our sample room, so we could compare our brand versus their brand. And so I took home the Tasco 50, but I also took home a Meade 16-inch telescope. Okay.
Yeah. No.
Set up side by side, and you could see the scarring on Jupiter's surface with the 50 millimeter toy telescope. And of course, the 16-inch, it was, you know.
Yes, was visible with a if you had for bigger telescope, was more, you needed I remember with my 8 inches, I needed to see the a filter. I don't remember if maybe I used it because when you put I remember I think that I used a blue one because I was so and my anxiety they say, you know, I need to see this, but I don't remember. I see something that I have clouds later in Buenos Aires, but for me it's visible. Come on.
Yeah, it was visible. It's true.
Yeah. No. It's one of the most incredible things that I saw at telescope.
I think a lot of people say that.
Yeah.
Yeah, absolutely. Mm-hmm. And we have the hero of the night tonight.
And our hero's here. Right.
Yeah. Yes, absolutely. And I remember that the idea, I don't know, but I think that the chapter of the Simpson, I think that was inspired in the idea when the idea that Bart Simpson found by telescope a comet, and the comet is going to Springfield. Do you remember? I think that was inspired in the history of discover a comet that impact in Jupiter. Yeah, because it's from the same time. I'm not sure about this, but
I remember when they confirmed that this was going to happen, I could still hardly believe it was going to happen. You know?
Yeah. No. This is the
what?
Yeah. Yes, I have a comet. I have another thing more.
Right.
It's incredible. I don't know how was the real history, but I really, really amazed
Hello, Adrian.
Hello, Adrian. Amazed or excited to listen this.
Yeah,
How, Adrian? In the
Doing
car,
good.
driving.
Yeah, as usual, but I am not.
Hi, Cameron.
Oh,
You driving?
hi. Hi, Caesar.
Are you?
Hi, everyone.
Cameron, how are you?
Good. How are you? All right.
Yeah.
Adrian,
How is
towards home
everyone?
or away?
Oh, Adrian, you're on the road. Wow, that's awesome.
Yeah.
Stay safe.
But I will be at home
Sir.
shortly.
Oh, cool.
Yeah.
Hey, Karim.
Hey, how you doing?
Good.
Hi, Karim. How are you? It's
good.
okay. The weather, the hot summer. It's the high temperatures are finished. It's okay now.
It's
more
cooled
than
down a
normal.
little. Yeah, it's
Okay.
cooled down a little, but there's still some wildfires in DC, unfortunately. But I was seeing the temperatures in other parts of the world right now. I'm in Kuwait. It's ridiculous. I feel for them.
Oh,
It's
come
just
on.
insane.
Yeah.
No, yeah. Yes. We are really very worried by Canada. The temperatures were totally insane. It was incredible.
We've been lucky; it hasn't been too bad most of the time here. So
Yeah. Yes, it's for not all people. Sometimes it's possible because it's logical here. I remember that maybe 2 years in summer in the south part of Argentina is Ushuaia, and Ushuaia have normally, the temperatures of maybe Canada, or they had 30 degrees, only 30 degrees that centigrade in summer. Of course, that they don't have the problems that for Canada was higher, over 40, 45, and 50, but only with 50 degrees centigrade, yes. And in Ushuaia, the people was turned crazy because they don't have air conditioner normally, because they don't need it. All people going to the fresh water because they needed keep their because the body of the people in the south is not prepared to only 30 degrees. I can imagine if you have 50 degrees, because it's totally unreal. It's incredible.
Well, we've got people already logged in and chatting here. We got Book Davies here, says hello to everybody. Beatrice Hines, hello everyone. Greetings from Belgium. Book Davies is on, and Beatrice says hello, Scott, Caesar, and David. Hello back. Harold Locke, good evening, Comet watchers. And Aaron Thompson, hello and good evening. Norm Hughes, good evening, all you crazy star people. We are crazy. Right.
Why crazy? Why?
That's right. Of course. Of course. The
Yeah.
later it gets, the more crazy we get. Hi from Oracle, Arizona. Just had a severe thunderstorm that dropped 1.2 inches of rain in less than an hour. Got 0.7 in the first 30 minutes of the storm. That was from Mike Wiesner. Book Davies has got his scope out and warming up. And Andrew Corkill's on with us. Let's see. Who else? Martin Easterburn, Cameron Gillis, who'll be on the show.
I'm
Yeah.
here. Yep.
So, and Chris Larson, Wade Prunty.
In 1743, observers claimed to have seen a comet with 6 tails. Little did they know that the streaks behind the comet could be related to the origins of the solar system. In time, scientists theorized that the dust in a comet's tail had been combed out into bands known as striae. How the striae formed, however, was still a mystery. How dust behaves in a comet's tail is exciting because comets are the leftover building blocks of the solar system. By watching the material clump and fragment in the tail, we can gain insights into the same process that forms dust into planets, moons, or asteroids. In 2007, researchers were able to capture images of Comet McNaught with NASA and ESA's SOHO and Stereo spacecraft. Today, researchers are introducing the latest step in analyzing footage like this, a new image mapping technique. When the technique is applied, it seamlessly combines perspectives from multiple spacecraft, giving us a clearer picture of how the dust trail changes over time. In the processed footage, we see the new striae form. Their alignment relative to the Sun indicates that the star might play a role in striae formation, as well as fragmentation. We can also see how the clean lines are disrupted when the comet crosses the current sheet, the boundary where the solar wind's magnetic field changes orientation. Notice how the defined lines become broken. This tells us that the dust is charged, and the characteristic lines of the magnetic field in the solar system are affecting it. Scientists can use the new processing tool to study dust behavior in other comets. When it comes to learning how comets can teach us about our origins, we've only just caught this by the tail.
It's your turn, Scotty.
My
Take
turn.
your own, Scott.
Here we go. How you guys doing? Anyways, Scott Roberts here, and this is the 54th Global Star Party. And I was reading something. Sorry, guys, but this particular Global Star Party is about the impact of comets. And maybe very obviously we can think about comets smashing into things, but comets have been impacting humanity for thousands of years, and it is something that that a lot of amateur astronomers can point to as kind of like the inspiration for why they go out and observe every chance that they can. I can't tell you how many people got started because of Halley's Comet or Hale-Bopp, or going back before Halley's Comet, like Comet West, or Ikea's Psyche, many comets that have been visible and observed, and and there's more to come, of course. So they are incredibly beautiful when they're bright and make these huge tails, but they're also very interesting to watch, even if they're small and you need some aperture to check them out, because these things are moving across our solar system. They're icebergs of primordial ice and dust. The leftovers are maybe the beginnings of our solar system, and all frozen up in those icebergs. And so, and I remember also giving lectures about Halley's Comet, and I kind of focused on how people thought of Halley's Comet in 1910. There were people buying comet pills, and they were buying gas masks, and because they had taken spectra of Halley's Comet and found cyanogen gas in the tail. And the comet came so close that the orbit of the Earth was supposed to pass through the tail. And there were people thinking, well, maybe we'll all die, okay, as the dust and gas enters into our atmosphere. But somehow we all made it, and you know, I got to see it, of course, in '85 and '86 with a bunch of other people. But I got to meet people that remembered it from 1910, and that was amazing. So I'm pleased to present David Levy. Yeah, I think all of us here are very excited. You know, we have David at every global star party, but you know, this is an opportunity for David to really talk about comets, something he's devoted most of his life to, and he's going to have a discussion group with us after we run through some talks here. So I'll pass this over to David.
Well, thanks, Scotty, and it's a pleasure to be here tonight. My leading of a discussion about comets is going to happen a little bit later. For now, I'm just going to do the weekly quotation. And because we are talking about comets, I really had to look very hard for my magic book to find a poem that doesn't have comets in it, and I did. And it's a very famous Canadian poem called The Cremation of Sam McGee. And I know that all the Canadians in the audience are laughing and smiling right now, because they all know, and a lot of the others know, just what a wonderful story this is about about this person who went up, who was going on this expedition, and it's about Sam McGee, who was, of course, born in Tennessee, and he went up to search for gold, but he couldn't handle the weather. And he knew he was going to die, and he made the speaker of the poem promise that if he died, that he must cremate the remains of Sam McGee, and the speaker agreed to do that. The next day, the cold was too much, and Sam McGee passed away, and he's taking it, and it's just a horrible thing. He's having the remains of Sam McGee in on his sled. And they finally find a ship, a boat that was sitting there crushed and destroyed in the ice, but a place where he thought he could build a crematorium. And I'm going to pick up in the last couple of stanzas of this poem. I did not know how long in the snow I wrestled with grisly fear, but the stars came out and they danced about ere again I ventured near. I was sick with dread, but I bravely said, I'll just take a look inside. I guess he's cooked, but it's time I looked. Then the door I opened wide. And there sat Sam, looking cool and calm in the heart of the furnace roar. And he wore a smile you could see a mile. And he said, please close that door. It's fine in here, but I greatly fear you'll let in the cold and storm. Since I left Plum Tree down in Tennessee, it's the first time I've been warned. There are strange things done in the midnight sun by the men who moil for gold. The Arctic trails have their secret tales that would make your blood run cold. The Northern Lights have seen queer sights, but the queerest they ever did see was that night on the marge of Lac La Barge. I created Sam McGee. Back to you now, Scotty, and I'll see you in a few minutes.
Very cool. Okay, all right. So we're going to move up our schedule a little bit here. Our next person that will be on will be John Goss, and John is with the Astronomical League. He how many times have you been president, John? 10 times.
No, I was president for 2 terms.
Two terms. Okay. Yeah, there's several 2-term presidents, I think, for the Astronomical League. So, it's I remember being there with you on stage and announcing National Young Astronomers Awards. And John, I think that you did a great job. You're certainly a leader of the league and powerhouse and driving force in amateur astronomy. And so it was an honor. A couple of times I was a little nervous. I'm sitting there in my suit.
I have one time in particular in which we were at an Alcon and Charlie Bolden, the NASA administrator,
right.
the top guy in NASA was our speaker. He was
That's
there.
Right.
And I was pretty nervous. And you were saying, no, just calm down. This guy is like everybody else. And well, yeah, he really was.
He was. I mean, you meet people that are brilliant and do these amazing things, but and it's not easy sometimes when you're around someone that you admire so much to just be yourself. But that's the way they want you to be.
Well, Charlie and I had a really nice talk about why we like ranch dressing on our salad. So that kind of smoothed it pretty quick.
He was a very nice man.
He is like everybody else. So.
Yeah. Yes, he is. Yes, he is. Yeah, except he ran NASA for a while.
Oh, yeah.
Just that.
Scary time. I don't know.
All right. So what will happen is, the Astronomical League comes on every week to do door prizes during the Global Star Party, and they set up the questions and give out the answers, and they give you a chance to win some valuable door prizes. They also, touch on, solar safety and what the league has to offer, if you were to join as a member. So I'm going to turn this over to you, John, and thanks for taking on the role this week.
Already? See if I can find it. Is this being broadcast, my slideshow?
Yes, it will be when you share it.
Well, I thought I was sharing it. Okay, let me try again then. Ah, there it is.
There we go.
Okay. So, not to outdo anybody here, but this is my lame attempt at poetry. Poetry about comets. Because you might remember last summer we had a very special one. Last summer's surprise. A wispy snowball named Neowise surprises in clear midsummer skies. Morning in Auriga, evening below Ursa, a wonder in our excited eyes. Neowise wasn't a stunning comet, but it was certainly the best one we had in quite a while. So it captured a lot of people's imagination. We're very, very, very lucky to have it. Let me move along though and talk to you a little bit about Alcon. This is just going to take a minute here. Some of the speakers on tonight's show are scheduled to be at our Alcon convention in August. David Eicher and David Levy. Evidently, you have to be named David to be in it, but that's the way it goes.
That's the way it goes.
We have a whole bunch of speakers.
Or David.
10, 15. What's that? But okay. Well, we have a number of speakers spread throughout 3 days, and in that time we'll have a lot of door prizes, a lot of awards. If you've been to an Alcon before, you know the routine. It'll be a lot like that. So it should be pretty informative for us. But some of our major speakers, if I can see here, Dr. Jocelyn Bell Burnell, who is somebody at least in my mind is the pulsar person. She's the one who was at the very beginning, who identified these things, who understood them or tried to understand them, and made a lot of advancements. So we're very lucky to have her speak all the way from the UK. Of course, David Eicher, David Levy. We will also be having Kelly Beatty. So we don't want to have David Eicher just out there by himself. We're going to bring in Kelly Beatty as well, and a number of other people. We hope to have a virtual tour of the Very Large Array, which is always a pretty cool place to go. If you've been there in person, it's a place that you will never ever forget. But this is coming up in August 19th to the 21st. It's free, but you do have to register. And registration is easy, and I know because I registered today, and it took like 30 seconds to register. All we really want is your name and email address, and then you're in. You're cool. So go ahead and think about attending. Oh, and one more thing, it'll be broadcast globally, and there's going to be a global star party that night. So on the Saturday night of Alcon. Grand prizes are for our door prize will be the thanks to Explorer Scientific and Scott, thank you, for Maxi Cassegrain 127. We will be having binoculars. We'll be having a whole lot of gift certificates and many things to do with astrophotography, books, sky guides, a lot of discounts. Anyway, it'll be worth your time tuning in, and you might even learn a thing or two, and I might learn a thing or two as well. Well, I'd like to start off this door prize section here for tonight. We'd like to start out generally by reminding people on the hazards of looking at the sun, although none of our 3 questions really have much to do with the sun tonight, but still, we want to make sure that people understand about the hazards of going looking at the sun through optical equipment. Got to have the right type of filters. Got to make sure they're at the front end of the telescope, not really fitted over the eyepiece. Pretty clear stuff that we say all the time. So, and looking at the sun is very, very rewarding. You know, we do have a solar eclipse coming up in another just under 3 years. So what we're going to be seeing are a lot of solar glasses out there. But you don't want to use solar glasses when you're using a telescope. That's no. Solar glasses are just meant for the unaided eye, or you can wear your typical prescription glasses, but they're just essentially super sunglasses, specially made to look at the sun. Okay, we'd like to go over the answers from the last star party, which was a week ago. We had 3 questions. Question number 1, here am I saying we didn't talk about the sun this time, but why does a total solar eclipse not occur at each new moon? Well, it turned out it could be answer number 1. It's because the moon's orbit is tilted just over 5 degrees relative to the Earth's orbit around the sun. So that means that at certain new moons, the moon passes above the sun along its path or below it. Once in a while, though, it occurs right smack on the sun, and that's when we have a solar eclipse, total solar eclipse. Question number 2, how close to Earth is the aurora borealis? It's interesting. I've never really thought of it like this, but actually it's not far at all. It's probably closer to you. If it's overhead, it's closer to you than it is probably closer to your next major city from where you live. Usually it appears about 50 miles above the Earth's surface. That's not that far.
Pretty close.
Yeah, you know, if you drove a car up there, it wouldn't even take an hour to get there to where these things occur. Question number 3. This is a good one this time of year when you're pointing things out to the public to make sure that you know this, because this is a great sky mark to help people find themselves around, find their way around the summer sky. What are the 3 defining stars of the summer triangle asterism? Okay, well, that would be the stars Vega, which would be the brightest, Deneb, which would be the farthest, and Altair, which is the southernmost of the 3. That's number 3. Okay, so we have the winners for this week, which will be added to the door prize drawing. I'll read the names off quickly if I can pronounce them. We'll see. Barbara Harris, Josh Kovach, Cameron Gillis, Israel Monteroso, Andrew Corkill, Norm Hughes, Adrian Bradley, who's on our screen right over there. Hi, Adrian. And Conal Richards, which is also on our screen someplace. So we have you guys here. So those are the winners who from last week. They will be entered into the next drawing. Questions for this week, though. I'll try to make this not too long or too painful. Please send your answers to the secretary at astronomicalleague.org. Don't send them to me. Don't send them to Scott. They go right to our secretary at astroleak.org. And then you'll be entered into next week's, or this week's drawing. Did I say that right, Scott? I think I did.
You said it right. Yeah.
All right. All right. You'll get in big trouble otherwise. Question number one. You know, I like pointing some things out that tonight, that's right, tonight, right now, we are 1 week shy of 2 years after the 50th anniversary of Apollo 11. So we're pretty close to the 52nd anniversary of Apollo 11. But at the end of this month will be the 50th anniversary of Apollo 15. So remember, the moon landings just didn't end at Apollo 11. They kept going for 3 years after that. So, you know, we're into the Apollo 15 time. So the question is, which of these mission highlights was not part of Apollo 15? So you get your book out and start seeing what was going on back then. A, establishing Tranquility Base. Okay. B, use of the first lunar rover. C, the feather and hammer drop physics demonstration. So if you want, another thing, if you want to relive how the moon looked in the sky during those times at the end of July, observe it on the evening of July 18th and on the following 2 nights. That would be the approximate phase that the moon was in when Apollo 15 touched down. And while the astronauts were there for a couple of days, 3 days. But if you want to telescopically observe the area, the best day to see it, to see this region where Apollo 15 was, would be July 16th at about 9 p.m. July 17th will work also. So if you really want to take a good look at the moon, try one of those 2 nights, and you'll be able to see the area and all the geographic features that the moon that they examined. So that's question number 1. Which one of those 3 was not part of Apollo 15? Question number 2, which I always ask them, because I like people to think about where we are in the actual solar system right now. Things change. Which of these major bodies of the solar system is closest to Earth tonight? So right now, essentially. And of course, I got my lame drawing there of the Earth off to the side, but you get the idea. Is it A, is the sun the closest? B, Mercury? C, Venus? D, Mars? It's always one of those 4. So which one is it for tonight that the Earth is closest to? Question number 3. Okay, on the evening of July 18th, the moon hangs to the left of what wide double star? It will make an interesting sight in binoculars. This star is a member of the Astronomical League's Double Star Observing Program. It's worth your time to take a look at this and to show your friends and neighbors, because it's something that they can actually view through binoculars. Is the name of the star Antares? Is it B, Zubanel Janubi?
That sounds right. I've heard it pronounced before, yes.
Zubanel
Janubi.
Making kind of groovy. Okay.
It does.
You're trying to make fun out of this. I don't know. Or numbers, or letter C, Spica. One of those 3, Antares, Zubanel Janubi, or Spica.
Well, the question is Spica pronounced Spica or Spica? I think I've heard both.
Spica, it's kind of hard to say sometimes. Now, Adrian, I think you're up in Michigan. I don't know what the preference is up there, but
it's Spica.
It's
Spica up here.
There's tomatoes and there's tomatoes.
Yeah.
So,
Yeah.
Speaking of Spica, so that's it. That's what I have, and we won't be here next month simply because we got Alcon going on. So all our people will be focused their efforts on getting that underway. But we will be back in September 17th for the next Global Star Party with the Astronomical League live.
Number 9.
Okay.
Yeah. That's great.
Number 9.
Yeah. Astronomical League Live 9. That would be great. Wonderful. Thank you very much, John.
You're welcome.
We are now going to switch back to David Levy. He had a great idea about having a discussion about comets, and I love it. And so, who better? It's like learning how to box with Muhammad Ali. I mean, so this is it doesn't get any better than this. So you guys in the audience, if you have questions about comets, okay, you want to try to stay on topic about this, but I will ask your questions as the discussion rolls along, but I'm going to turn it over to David. So David, thank you so much for doing this. This is wonderful.
Thanks, Scotty. This is my pleasure. The most important moment of my professional life took place at Palomar Observatory at the bottom floor of the 18-inch telescope on March the 25th, 1993. 2 nights earlier, we had taken some pictures using film that wasn't really very good of an area of the sky near Jupiter. And on that afternoon, I was sitting at the desk in the room there. Carolyn was scanning with the stereo microscope, and Gene Shoemaker was sitting on a chair reading Time magazine. When Carolyn stopped, looked up and said, "I don't know what I've got, but it looks like a squashed comet." And whatever a squashed comet looked like, Gene and I wanted to see it. And so Carolyn got out of her chair, and Gene went down and sat down. And Carolyn was near me, and I looked at her and I said, "You're joking, aren't you?" And she looked at me and she said, "No, I'm not." And Gene then looked towards me with an expression of unbelievable bafflement that I'd never seen before. And then I decided I had to take a look at it myself to see this line of comets, each one with the tail going up and the bar joining them all and extending off either side. That was the discovery of the comet that later became known as Shoemaker-Levy 9. I've made two good decisions in my lifetime. The first one, beyond a shadow of a doubt, was meeting and marrying Wendy. And since Wendy is sitting over here, she knows that I would say that, and I better say that, because I can't wait to stay married to Wendy, and I'm very pleased about that. But the second most important decision I made in my life was a decision to start searching for comets on December the 17th, 1965. And I'm still doing that now. My last visual discovery was on the 2nd of October, early in the morning, 2006. And that's the most recent discovery I've made, about 1,200 hours of visual searching since then. And it's been a real pleasure. Of all the comets that I've discovered, by far the most important one has got to be Shoemaker-Levy 9. It was not that bright. It certainly was no Hale-Bopp. It was no Halley's Comet. But it was the first time that a comet actually gave humanity a lesson on comet impacts, on what happens when a comet collides with a planet, on what happens to the planet and what happens to the comet when a comet collides with a planet. This was really something. With everything going on in the world, you can imagine right now we have an awful lot going on in the world, but there's always a lot. There's always bad news, good news, mostly bad news, things happening in the world. But on that 1 week, we paused for just a moment to witness the wonderful story of 2 solar system objects colliding with each other. This has happened in the story of the history of the solar system. This has been commonplace. If you want proof, look at the moon. Almost all the craters you see on the moon are impact craters, the results of mostly comets and occasional asteroid impacts. The Earth has a lot of impact craters on it, including a very large one just off the coast of the Yucatan Peninsula. And that was made in about 15 seconds by the collision of a probable comet with the Earth 65 million years ago. And the Brontosaurus and the Tyrannosaurus Rex were looking through their telescopes, and they had their little laptops open trying to record everything and take pictures and trying to connect their meat telescopes to the computers and everything. Well, maybe they didn't. I don't know if the dinosaurs knew how to use laptops, but they sure were able to see that something really big was happening in the sky. And they must have known it was big because shortly after that, they perished. In fact, 95% of all the species of life, not the individuals, but the species of life then living on the Earth, were wiped out as a result of that comet impact. Is that going to happen again? Yes. Is there any doubt about it? No. What we don't know is when that is going to happen. We have no idea, no clue as to when that'll happen. The odds that each of us right here, Kareem, Adrian, Scotty, me, Cybella, all of us, the chances that each of us might get clobbered by an incoming comet during our lifetime are probably about 1 in 20,000. So it's not something that should cause you to lose sleep over. But if you sort of add all that up with all the people living in the Earth, on the Earth, and if you add all that up and average it and do the math and everything, it comes out to approximately a 50-50 chance that some sort of comet will collide with the Earth sometime in the next 100,000 years, which is a long time, but it's not forever. Now, that 100,000 years could be any time. It could be in the next 5 minutes, or it could be 100,000 years from now. And I think the most important contribution that Comet Shoemaker Levy 9 made was that it alerted the people of the Earth, the civilizations of the Earth, to this possibility, to this danger. And for just a few days, we paused and we thought about the awesome unpredictability of the universe and of what could happen in our solar system. That was an incredible week. We were in Washington. I got to meet President Clinton very briefly. I got to meet Vice President Al Gore not so briefly. We had quite a discussion about that. And he wasn't at all interested in talking about politics. He wanted to talk about comets. And he told me that he told me something that I did know, is that he lives on the grounds of the Naval Observatory. What I didn't know was that a couple of nights ago, he said, I went outside and I went to the observatory and knocked on the door. The astronomer there opened the door and met me. And I asked if it would be okay if he showed me the impact spots through the telescope. And it turned out that Al Gore got to see the impact spots before I did. And I was really pretty glad to hear that. But just 2 nights later, I was part of a large group of people that assembled at the Naval Observatory and stood in line to look at the impact spots from SL9. And I got to the back of the line, and as I stood, people were pushing me closer to the front of the line, and I kept on fighting them. I said, you know, I don't want to be the first one. I want to take my place in line. And I got up to a lady who was there, and she said, David, you're going to wait with me and we'll see the impacts together. That woman was the astronomer Vera Rubin.
Wow.
She was at the time, the scientific advisor to the president, and someone who later won the Bruce Medal of the Astronomical Society of the Pacific. Really a very, very special astronomer, after whom an observatory in the Southern Hemisphere is now named. There's the Vera Rubin Observatory, named now in her memory. This was a really very special thing. But I wanted this to be a discussion. And after this brief introduction and personal view, I'm going to open this now to all of you to ask questions and just share discussions, pictures, and stories about comets.
Wonderful.
That was beautiful. That was beautiful, David. I especially appreciate and I love the humility that you and the grace that you've in your whole journey. This is not about fame or anything. This is about the journey of discovery and sharing that, and what you contributed to humanity is fantastic. Giving everyone a glimpse of the significance of comets and showing the impact they've had on life as we know it.
Well, thanks, Cameron. I remember one thing that happened. The discovery itself, this was before we knew what was going to happen with SL9, but the discovery itself was something really unusual. And I remember the day after we reported it, at the time I was writing a column in Sky and Telescope magazine. And I called my editor, Steve O'Meara, and I left a message on his phone. I said, "Hi, Steve, this is David. I'm calling you from Palomar. I need to talk with you." And the phone rang again about maybe 5 minutes later, and it was Steve, and he said, "Whenever you call me from Palomar, it's got to be important." And I told him about the discovery, described it, and I told him I'd like to write one of my columns about this discovery. And he said no. And I said, "What do you mean no? It's my column. I want to write about this comet that I hope to discover." And he said, "This thing is for the front of the book, not the back of the book. You're going to write an article about your discovery that'll be in the front of the magazine." And that's what I ended up doing. But at the time, that's not what we didn't have any idea what was going to happen. It was just an interesting comet at the time. We didn't know that it would turn out to be as important and as interesting as it eventually turned out to be.
Cam mentioned humility, and I can't imagine having discovered the comet with Jean and Carolyn and the impact and wanting to see the impact marks and waiting in line and not telling them who you are, not saying, just waiting at the back of the line, waiting your turn. That's who you are. It's amazing. One of my first experiences with David was at Westmount at Summit Circle, where we were sharing the night sky with the people he grew up with in Westmount, and he just stood in line at the back and waited his turn to come to the front to say he was there. We had no idea he was there till he showed up at the front. Well, that was kind of fun, and I enjoyed that line. Of course, that week most of the people did recognize me, and as soon as they did, they pushed me further to the front of the line until I bumped into Vera Rubin. But that was an interesting week. I got to tell you, it was the highlight of my professional life, beyond a shadow of a doubt. Certainly not the highlight of my whole life, Wendy, but it was the highlight of my professional life. And Wendy, we can attest to the fact that he says this even when you're not listening.
Yeah, we all can.
Yeah, that's true. Yeah, I've seen David give a few lectures, and he always gives tribute to Wendy when Wendy's far away, So Wendy's had a huge impact on David's life.
One of the real advantages of the COVID thing and Zoom is that Wendy is about maybe 15 feet away from me right now. And for all of these sessions, she usually is. And that's a real pleasure. So it's one of the real advantages of doing it this way.
Yes, that's right.
Yeah, I think that's the interesting twist of this whole thing is I think it's brought people closer together. It's certainly in this community with families. I think people are forced to face the reality of nature, and it's I think it's a wonderful thing. There's some challenges, obviously, clearly, but it's all part of our growing and experience, and so I think it will all work out in the end.
I hope so.
And like John mentioned, our whole experience with COVID last summer was, I guess, relieved by the fact that Comet Neowise was there. We got to share it with each other, share it with the world. And right now, I'm getting Facebook popping up the memories, 1 year ago, and I'm just seeing all the pictures of Neowise. And we started last summer really diving into Zoom, talking comets. So it's kind of nice right now towards hopefully the end of the pandemic time to be returning to talk about comets. It's a nice full circle there.
Yeah, maybe this large comet that has been detected and will be the harbinger of the end. We had Neowise as sort of a messenger during the height of the pandemic, and I remember imaging it, and people would come out and ask, "Do you see the comet? Do you see the comet?" And it would be twilight, and those of us that were experienced visual astronomers would look up and see the light from the comet right away, and the general public struggled. There were some concerns with some of the general public at the time. Masking was recommended everywhere, and there are many in the general public that didn't. So we had to fight some of the contention and the concerns about people coming up to you right to your face and going, "Do you see it? Do you see it?" And saying, "Well, I do, but you might not." But once it got dark enough and then you could see the comet hanging there, lots of people were out. I remember the dark sky park that we live near, and there were more cars there than at a basketball game during normal times. Not only did the comet bring people out, nature itself, the nature centers had cars parked all the way down the street of whatever metro park that we were in. I was thinking, is there a basketball game here or something? But no, it was people were looking for something to do and they were getting back to nature. Neowise was the one of the things that really brought people out. People began to pay attention to the outdoors. Some maybe because there was less chance of catching COVID there, but most reconnected for that brief period. And as states have opened up and you go to the nature centers now, you don't see as many people, the cars, it's back to emptier lots as people have gone back to the restaurants, the bars, and the places that they would rather socialize. But for that brief time, nature was on display. One more quick story about Hale-Bopp, the even brighter comet. It's a shame I wasn't doing photography at the time, because when Hale-Bopp was out, I was flying in a plane towards Arizona on the window side, and I got a perfect view of that comet. We see it in the sky, naked eye, kind of like we did Neowise. You could see some of the tail. I was up in the sky, and where it was dark, I saw the entire thing stretched out across the sky, and just remember observing how much bigger that tail really was and how large the comet itself looked, and thinking, yeah, if that hits the Earth, we're done. The fact that it was further away I don't recall, those of you that are on this call, was it how much further was it away in terms of Earth moon distance? I thought it was like couple of times the Earth
It
moon
wasn't
distance.
even close. It was not even close, Adrian.
Yeah, so but yet it stretched out. I think I was looking south, and it stretched out the entire length of the, from the southeast, southwest. It was the entire length of the sky, and that far away. It's kind of chilling to think, well, if something like that comes and hits us, you worry that it'll split the planet in half. The planet itself probably survives. We probably either fly to the moon or the moon gets caught up in it. It was a really big comet, and I just remember thinking that as I was on that plane. So
The scale was about 31 million miles long.
okay.
One thing that I'd like to say about Adrian, while we've got him here, is that he owes part of his beautiful astrophotography inspiration to a dreadful picture that I took a number of years ago when I was in Brazil. I was at a conference in Brazil and staying in a hotel, and it was really very nice. But as I'm walking through the parking lot of the hotel, I looked up over the parking lot light and saw the Southern Cross just sitting there in the sky. And I said, I got to get a picture of that. And I set up my camera, put it on a tripod, and turned it up. And I got this horrible picture that shows the light and the reflection of the light, and this and the light and that and the light. But on top of it all is the Southern Cross. And Adrian still says that that was his inspiration to get into astrophotography. I'm really very sorry to hear that, Adrian.
Well, you could look at it this way.
Wonderful pictures.
So the reason it is that despite it being a picture, and it's actually on my phone, I was just looking for it to see if I could share with the audience just what this picture was, and I'll keep looking. But it was the fact that you captured the starlight. There it was, the Southern Cross, something that I, to this day, haven't seen. And, Cesar gets to see it all the time. He wants to see the Big Dipper.
Yes.
I take pictures of the Big Dipper because those in the Southern Hemisphere,
yes,
the Big and Little
impossible to
Dippers.
see.
We have parts of the sky that we don't get to see each other. But I guess what was profound about it is that these stars, look at the back of my picture, these stars are, they're light years away, some millions of light years away, and yet you captured them on camera. I could see them. It was something that, like most folks that don't know enough about photography to begin with, you don't know, we can't capture stars. How do we do it? Everyone wants to keep the ISO at 100 or, whatever, they do. But once I saw capturing stars was possible, it just lit a fuse. And, it's led to being able to do so, or to capture stars. Now it's what I go after all the time. At some point I'll find a photo. We'll let others recollect things, but I'm going to look for that photo, and if I find it, I will share it with I'll share it with everybody.
I think everyone here, I mean, each of us, many of us anyways, I would say, have observed comets before. So why don't we take turns here and tell about our most amazing comet experience? You want to get started, Conal?
Yeah, mine's already done because that was mine. Seeing Hale Bopp in an airplane, so everyone else gets to go.
Experience.
Yeah.
How about Sibella? Did you see Comet Neowise last summer?
Did I?
I did, yeah.
Okay, tell us about it.
So my mom and we found this really high hill where we live, and we had a telescope. I think we actually used my dad's telescope. So we set it up, and we got an amazing view of it. And I think I forget if we were able to attach the phone to the telescope to take pictures, but it was really cool to see the trail.
Yeah. Well, that's very interesting. And I hope that will inspire you maybe to go find and look at other comets as time goes by. And especially since you're just at the start of your life now, And you have many, many years ahead of you
Oh, yeah.
to enjoy that and enjoy the night sky.
Who's next here?
Well, I'll go ahead and share.
All right.
So I've seen 3 comets so far in my observing career. I remember the first was very exciting, Comet Johnson in 2016 with my telescope, and it kept progressing. It was a small comet, only 10th magnitude or so. 2 years later, I found Comet Weirtanen in binoculars. I remember I was looking in Sky Safari or something like that and saw it was bright enough. And I ran outside with my binoculars in a beach chair, and that was a spectacular view. But that was all in preparation for my best memory, like many of ours, of Comet Neowise. I was working as a lifeguard last summer, and I had an early shift that morning. It was starting at 5:30 or something like that. I was opening the pool, and I thought, all right, I'll get up just an hour earlier and see what this comet's all about. I'll get some binoculars. 3 months prior, I'd gotten into astrophotography, and I thought, well, there's a lot of buzz about it. I'll see what it is. And I went down to the end of the street, and I was looking around Auriga, and it was maybe 30 minutes before the sun came up. So of course it's very bright in the sky, and I finally centered it in the binoculars, and there was no mistaking it. It was stunning. I had a 5-degree field of view, and the tail filled it up. I had to say it was about 6 degrees long. And if I can share some images here, I remember I was looking down the street, and
oh, there you go.
That's gorgeous.
This was the view I saw, and I'd only been starting in astrophotography, so I finally got it. It was just below the trees, and it's one of my favorite shots to this day. I saw the nucleus of the comet, and I got some later on. If I can proceed forward, I was experimenting with the ISO here. I'm in the folder of images, and then I got this one. You can see there's still a little bit of noise in it, but again, this was looking down the street, and the nucleus is there. And the tail very delicately curls up into this, winding fan kind of shape, and just barely dissipates out. It's very hard to see where, but it's very gentle and subtle. But that was a little bit what it looked like in the binoculars. But as many of us as observers know, it never does it justice. It was beautiful, and I knew I had to share that with everybody.
I love the cloud cutting across the tail.
Yeah,
that adds to it.
Yeah,
thank you. I got lucky with the perfect conditions. You don't always want clouds or trees or twilight, but it worked out to create a beautiful image that I remember firing that off, before I got to work. I might have even shown up late that day if I'm guilty, but I fired that off in text messages and emails, and all my friends and family I knew they had to see it. And I was like, look at the comet, look at the comet. And I had to be glowing for a week after that as I kept observing it. Truly a remarkable memory.
Conal, I don't blame you. I know that feeling. And of all the comets that I've seen in my life, the one that gave me that feeling, the way all do, was Comet Yakutaki.
Yeah.
Not Hale-Bopp, Yakutaki, which was the year before Hale-Bopp. And the night that it was at its best, I could see the head right near Polaris. And I followed the tail all the way across the sky into Corvus in the southern hemisphere.
Wow.
Yeah.
And, I reported that, and professional astronomer of JPL said impossible. The comet's tail, if it were to be that long in the sky, would have had to stretch all the way out to Jupiter, which is impossible. Anyway, a couple of years later, there was a report that the Ulysses space probe, not far from the orbit of Jupiter, had recorded that it went through the edges of the tail of Comet Yakutaki. And the fellow wrote me back and said, guess I was wrong. I guess you did see what you saw. I thought you saw. Never forgot that. It was great.
That's awesome.
It's a small digression, but I wish by now we would stop saying impossible. We know better by now.
The cosmos always surprises us. There's always something. I remember sharing my Weirtanen story, and it was a small 8th magnitude comet, but whatever I was doing just dropped, and I became an observer of the night sky. And Dr. Levy, it was it was very humbling to hear your story about just waiting in line and waiting to see what was at the telescope with everybody else. It does kind of give you some perspective, which is a really nice aspect of comets.
Oh, I think so. Thank you. I feel that the idea of going out and just seeing a comet just proves that the solar system, that the night sky isn't static. Things move through the sky. Shooting stars fly through the air. Comets gracefully move. And I like to make the difference between a meteor and a comet. When you see a meteor, it's like having lunch at McDonald's. You see a comet, it's like having tea with the Queen. But I did want to share one story about Neowise. Last year, there were actually 3 comets that all threatened to become very bright. The first one, I think, was Atlas, and that was going to be the great comet. And it was getting brighter, and I was watching it through the telescope and getting all excited, and then it went whoop, just got fainter and never did anything. And the second one was another one, the name escapes me right now, but it did the same thing. It brightened to about 3rd or 4th magnitude, a little too close to the sun to see, and then just never got any brighter, better than that. And I didn't see that one at all. Then came Neowise, and I thought, well, 3 for 3. But that morning when I went outside, the full moon is setting in the west. The dawn is coming up in the east. I had this pair of binoculars and I could see Capella just coming up. And I just put the binoculars on Capella and just moved them slowly down to the horizon. And suddenly there's this boom, just like you saw, with this lovely tail. And I practically jumped out of my skin. I'll never forget these days. Yeah, thanks. Thanks for sharing.
We have some comments and questions here. What can you say about the idea of comets bringing water and creating oceans on Earth? David, is there any?
Thank you for asking that question. The answer, I have a one-word answer, 4 letters. It's CHON, C-H-O-N. CHON is the simple scientific alphabet of life: carbon, hydrogen, oxygen, and nitrogen. In Halley's comet in 1986, they discovered, and one of the most important discoveries made that year on Halley with the spacecraft, was they detected these CHON particles in Halley. And from that, you can think when a comet collides with a planet, like comets have collided with the Earth in the past, they bring with them these simple elements of carbon, hydrogen, oxygen, and nitrogen. And they kind of just sit there and they do nothing on the Earth for eons and eons. And then gradually they become amino acids and proteins. And then after a very long time, they can become RNA, and even longer time, DNA. So I think Gene Shoemaker said it best when he said that we are the progeny of comets. If it weren't for comets hitting the Earth, we would probably not be having this conversation now.
Excellent. Okay. Excellent. So Cesar, you must have seen some great comets in the Southern Hemisphere.
Yes, was my first comet. Was not my first comet. The Halley comet was bright, but the tail was in an opposite direction to the Earth and don't have tail. Was in my time of my military service, I was in Santa Cruz. The Halley comet was in the sky, and of course, I was in the optical repair department of my military area. I had the opportunity to use a binocular in my wards, my nights, watching the sky more that the things is anybody coming to attack. Of course, that no. And Halley was amazing because was a time where I started to see with binoculars in a very dark sky, the sky. And my second comet was amazing because it was the Magno in 2007.
Oh yeah, Magno.
And was amazing, was unexpected for me because in the sunset was a very nice color in the sky, but a little fine detail. But when the night came over, maybe the nucleo, the center, the comet properly was maybe invisible because was under the horizon, but the tail was so big in the night sky. Going to the starting, I think that they started to the south west, going to the right, and the size of the tail was like maybe 50 degrees. You know, it's something like it's really something that is where you felt, I felt really little because the size of the tail of the Magno was really impressive. Unfortunately, I don't have in this time my digital camera. I took a picture with my analogic camera, but you know, it's impossible to describe when you see something in the camera. I see the pictures, many pictures from the Magno from Argentina, but anyone describe the impressive that you feel when you see it's. I think that was like to see an boreal south northern lights because turn really impressive, brighter than I imagined. I could imagine it. It was really easy to see, very impressive in the sky. Incredible.
Yes.
Well, that is a really interesting story. It reminds me of my best view of Halley's Comet in April 1986 from Cuzco, Peru.
Wow.
And seeing it there was just wonderful. You may remember that was the night before the great Cuzco earthquake in 1986. I remember the next day just sort of laying down for a nap, and suddenly the whole building started to shake as if it was going to fall down.
Oh my God.
Wow. Wow. Comet, earthquake. Come on,
Wow.
David.
That's right. That's right.
Yeah, I can't believe that. It's so too much experience in today's.
Yeah.
I have a very short story about Halley's Comet. It was during a time when I was getting more and more involved in what I would call serious amateur astronomy. I had a 13-inch Dobsonian telescope, and I was taking groups out to go observe Halley's Comet. But there was one particular night where they were saying this would be the best night to see the comet. And this is in Southern California. And on that night, it clouded up and it started to rain. And I just go, well, no matter what, I'm going out to try to see this comet. And so I put my telescope, my 13-inch Dobsonian, on top of my car with surf racks. It's raining, okay? My telescope is really wet, okay? And I'm driving out to where I figure, okay, I'm going to drive out as far as I can, trying to go more eastward, but it's still raining. It's still raining. And I go, forget it. I'm going to get my telescope off my my vehicle. I'm going to set it up. I'm going to throw in my eyepiece. My eyepiece is dripping wet. There's water going inside the eyepiece. There's water all over the mirror. Okay. And I point the telescope and drain the water off a little bit, and the clouds part just enough for me to see Halley's Comet for about 5 minutes.
Did the angels start singing and music started to play?
There were two other people with me. They could not believe this happened. And
so Scott,
I love that
no
story.
matter what,
Yeah,
you need to go out and observe. You know?
And this is why I'm sorry, and this is why you design eyepiece waterproof.
Waterproof. You're right.
Yeah,
Good one, Caesar.
Right.
Good one.
we
Yeah.
understand now everything
That's
about
right.
the expert
So-
scientific.
that's more
right.
common
Why?
than you think,
Ah,
Scott.
have sense.
It very cloudy night, and the forecast was for cloudy. Unfortunately, it wasn't to see a comet, but something similar has happened twice. Going out to a dark sky park, nothing but clouds everywhere. And what tends to happen is for a brief period, the clouds clear and all of the stars come out. And when you're the only one there, or you've got a couple other people there with you, you almost feel like the clouds were parted just for you. There's a dark sky park I'd been to where it happened 3 times. And for me, I've got the Milky Way recollections later.
You will the clear sky.
Yeah, I willed the clear sky, and I could see the trail of the Milky Way in that sky. I think there was actually a comet during the winter. We had another comet, and imaging Orion, I actually caught the light from that comet, and it was in one of my pictures. And that's when I said, I wish I had better precision in my photo. So after that night, I had gone to order the tracker that I use now. So
that the fact you were out there anyways and doing it, that's what's really important.
That was the important thing. I did find the picture before we let Maxi talk about his comet experience. I found the picture that David showed us at the University of Michigan, and inspired me to take photos. That is the picture. No comments.
That is the Southern Cross.
Oh, that's the Southern Cross up there. I see it.
Yeah. So what I've done with your picture is, let's see if I can. Yeah, I zoomed in on the Southern Cross, and I've called this one David's Cross. This photo right here, and
you can see the colors of the stars. That's awesome.
Yeah. So you did a better job than you thought you did, David. You caught the color of each of these stars, and so that is after you sent it to me. I cropped it out, made that picture, and so now I keep that picture until I can make my own, hoping to have the cross in the exact same orientation, but with the Milky Way running by it. That's my goal, and if I can get down to Argentina at the right time, that's what I'm going to go for. So I got Cesar, you and Maxi. I'll be giving you a call as soon as they clean up international travel.
Anytime. Something. Sorry.
Just a minute. Your story reminds me of something that happened to me. I think it was January the 5th or 6th, 1987. It was a cloudy, rainy night. And I was finishing one of my books, a book on variable stars. It was eventually published by Cambridge Press. Anyway, as I was finishing it, I noticed the clouds were thinning, clear sky was coming. I set up the telescope and I went outside and discovered a comet. Wow. I went back inside to confirm it, and then the clouds came in again. And when I realized that it was probably a new comet that I had just seen, I looked outside, I saw the pouring rain, and I thought, God, did I just discover a comet through that? And I'll never forget that story. So even on a bad cloudy night, you never know what nature has in store.
You never know. That's right.
Right.
That's right.
Okay, now we have to go on to
Okay, Maxi.
Maxi.
Well, hi everyone. Hi Scott,
Hello.
David,
Hey,
uh,
Maxi.
Cesar, Adrian, Conal, Cameron, everyone. Well, first of all, I want to give a big thanks to Scott to let me be here. It's a privilege to hear to David Levy because today I was talking with Cesar a little bit, and that's remind me when I was a young boy, a little boy, when I was watching every time Discovery Channel, Nat Geo, and everything. And when I was watching documentaries of cosmos and space, I remember I saw that moment that the comet Shoemaker-Levy 9 impact to Jupiter, and I was blowing my mind. And every time they say these guys found this little comet and goes directly to Jupiter, and it was amazing. And then once the years goes by, and I thought that I never going to know to David Levy, and now I'm here talking to him.
Right.
You know, I'm almost 32 years old, and that was when I was 11, 10 years only. So basically, it was a long time ago, and that's another part of astronomy. It goes, and now obviously the internet, the connections, the virtuality, and obviously the GSP give me this privilege to be here with David and every one of you. Basically, my experience with comets was at the end of December in 2018 with the 47P Wirtanen comet. And I remember that was passing by through the Pleiades, and I wanted to capture and see it. And in my backyard, it was a little with the Bortley 6, it was almost impossible. I had my Maxi telescope, but I remember and only a night I went with my brother 10 kilometers away from the city, and we have our binoculars and only my cell phone with a simple tripod to get to start taking pictures to this sky and try to find it with the binoculars. So with all the stars that we see this little cloud, very thin, but with the core. And that was our first time that we saw this comet. And obviously, I can take some pictures with Orion and everything, and also with the comet. And so I decided to do some every for almost 4 days. I found the progress of the comet passing by through the I don't remember the stars, but I did some animation in that time. And then in 14th of December, we met with a small group of Astro Friends Argentina. Is a page from Facebook, and we met in Mercedes in the observatory to watch it with the I don't remember the telescope. It was 30 inches. Catadioptric telescope. I don't remember, Cesar, if you know. Are you hear me? Hello?
Yeah, we
yes,
hear.
yes,
No, we hear you very well.
yes,
Hello,
yes, very well.
guys.
Yes.
Can you hear us?
Hello.
Yes, we are
I
hearing
think.
you. Yes.
We
I'm
can hear
checking.
you. Keep
Yeah,
on
we
Oh,
can hear you.
I have
Yeah.
some bad connection for now, but like I say, we met in Mercedes, and with I remember it was Jose Sanchez and Mario Borelli. He said, I remember this guy with a telescope to say, oh, that I will give you to watch. I don't know, Centaurus A, and he put two only with his eyes without go to and everything. And obviously, I can take some pictures with that time with my cell phone, the Mac of the 47P Wirtanen comet, and I was shocked because I see how in sometimes moves it was very fast, and I did some animation of that movement, and that was my first time with a comet. Maybe it wasn't the Neo was from the last year, and I couldn't see it either because from my latitude it was very small. Like you saw with that tail and everything, but I hope in this December, I think it was the Lovejoy, maybe not, could see properly very good. So this is a little short story, and this is my experience. I had some experience last year with Lemon and another comet that I took from my house. I tried to figure out how to stack images to give pictures without have star trails and to give the singularity stars and the comet without movement. So it's a very difficult procedure, but you can do it because it's maybe tricking the images. So that was a little positive side of this virus that gave us to be in our house, so I can those pictures. I remember I woke up 4 a.m. of the morning, put my telescope outside, and it was in May, I remember, very cold, and I have to work 8 a.m., but I was in my house, so
Oh, no.
it doesn't matter. I will still wake up. But now, if I have to do now, I don't think so. But so basically, this is my little story, and I want to share it with you.
It's a good story. It's great.
And again, David, thank you, and it's a pleasure to hear you, and it's a privilege to me to be with you in this GSP.
Well,
I
thank
think it's
you,
good.
and feelings mutual. Thank you so much. And
Thanks.
I'm really pleased with the level of the discussion here with comet stories and things. There's so much, even without the pictures, there's so much memories and lovely stories to talk about. It's really fun.
Yeah, this is the impact of comets upon us, anyways. There's a question here. Robert, with Space Time with Robert, is on watching, and he says, during outreach, did you ever, if you did outreach with, showing the comet, did anyone coming up to the eyepiece think that the comet was in our sky, or did they think it was out in space? Did they? So this was. I wonder if he's asking this because he had an experience like this. He said, "How can someone tell without knowing about comets?"
That's a very good question. I'm really not sure how to answer it, but I'll try.
Okay.
I mean, we know that comets are brothers and sisters in our solar system family. And they go through space, we know that, and they, except for one, orbit the sun and are visible in our sky. But we know that the moon is in space. The planets are in space, just like Jupiter and Saturn were last December, and you can see them a lot further apart now. But they are at the same time in our sky so that we can see them. And the beautiful thing about our solar system is that, as I mentioned before, it teaches us that the sky is not static. Things happen. The moon moves a lot from night to night. In fact, it moves its own diameter about once an hour. The planets move slowly through the sky, some faster than others. And I mean, if we were living a lot longer than we do, we would actually see some of the nearby stars creep along a little bit. But that's the great thing about looking at things. We're looking into space. And of course, the ending of your answer is that the Earth itself, where we're standing, where we're walking, where we are sleeping, is in space. And so, yeah, everything we can think about is in space. And the best thing we can do about space is that it's nothing. There's nothing there. It's a total absence of everything, except for everything. I hope that sort of helps answer your question.
Wonderful. Okay. All right. And how about Kareem? How did comets or a comet impact your life?
Well, I have to give an embarrassing story where I was in grad school at the time of the bright comets of the mid-90s, and so I spent all my time working late nights at the computer and never really stepped out. And I was out of astrophysics at the time, and I was away from astronomy, so I didn't even realize Hale-Bopp had passed. I was so immersed in my little specialized world of grad school that I didn't know what I missed until years later when I saw pictures in magazines that I picked up, and I realized that I missed such an amazing comet. And so when Neowise was happening, I did not want to miss a moment. So I went out with the family, I went out by myself, but one of the really neat things we did is in the city, at one point, it was really hard to see Neowise to the north to the naked eye, but you could see it if you took a couple of pictures. So my wife and I went up, we went with the telescope, I set it up so we could just figure out exactly where it was. And then she set up a camera and we had the family come, and in discrete family units, we walked them up to the camera and they pointed to that space in the sky and we took pictures. So you could see their faces, you could see them pointing, and then with the mask, we could pull out the comet. And so we have a bunch of the family who had never seen a comet look through the telescope, see it for themselves, and then point to it. And that was a lot of fun.
Oh, that's cool.
A
That's
memory
cool
for everyone. Yeah.
Yeah, a comet that I wished I had seen was Comet West. You know, I was certainly interested in the stars and space at that time, but I didn't have anyone knowledgeable enough to say or to take me out to go observe this comet. So
yeah.
But I certainly made it up with a bunch of other comets. So, you know.
But I do want to mention that when, like in teaching, one of the really neat things that we've been talking about in class the last couple of years is pulling out stories of ancient astronomy observations of comets and of different phenomena, like the supernova, the Crab Nebula in 1054. But David, have you had a chance to see the Silk Atlas from China and the number of observations of Halley's Comet that are in Chinese astronomy writings? It's incredible.
Yes,
and
I have. In fact, some of the ancient silk paintings and engravings that come out of China, and in fact, the very earliest comet recorded in history, I believe, was seen in China, from China, about 1200 BC. or so. And that is approximately the time of King David. And did you know that every year at the Passover Seder, there is a quotation from Scripture that deals with a census that King David ordered in Jerusalem, an ill-advised census. And it specifically says, and the angel of the Lord hung like a sword over Jerusalem. And I believe that he's referring to that comet. And it's done every year at the Passover Seder.
That's so cool.
I was wondering, actually, Molly has joined us, and I'm wondering if Molly has any comet stories that she would like to share with us.
Yeah, actually, and I'm going to show some of my pictures during my my segment tonight. So I know a lot of people got into amateur astronomy by seeing a comet. I hear that story over and over again, either a comet or like a solar eclipse. That was not the case for me. And I saw some comets after I got into astronomy that I imaged in the eyepiece, but NEOWISE was really my first naked eye visible comet. Hale-Bopp came through when I was quite young. In 1997, I was 6. So sorry, everyone. So I was not paying attention to those things at that time, and neither were my family. But so for NEOWISE, so I was out in San Francisco, and I was looking for a place because it's quite low in the north. So I was looking for a place that would have good visibility for it. So I actually kind of scouted out on Google Earth a spot to go to on in Pinole, because I was living in Berkeley, and I went out there, but like the area that I was trying to get to was closed, and so I ended up like in somebody's backyard at like an apartment complex. It's like one of those like communal backyards. So it wasn't like an individual person's backyard, but I ended up in somebody's backyard, and through the trees, I was able to see it naked eye, like right at sunrise. I was out very early in the morning to try and do this, and managed to snag a picture of it. And then later on, when it was a little bit higher in the sky, I went home during the pandemic to go camping with my parents up in northeastern Washington. And that was up at quite a high latitude compared to where I usually am at. I was up at like 40, probably about 49 degrees north latitude. So it's a lot higher in the sky. And we were camping out at a dark sky site, more or less out in the middle of the Colville National Forest up by Canada, and had a really nice view of it from up there. And I got some really nice shots that I'll show in my segment tonight. So yeah, that's my comet story. The one and only naked eye comet I have witnessed thus far, and I think it's the 5th comet I've imaged, but certainly the best comet I've imaged.
Yep. There was Mike Overacker says in chat, I was fortunate enough to photograph Comet NEOWISE over a line of thunderstorms. Of the dozens of comets I've seen and photographed, that was the most memorable.
And I was able to get both the dust tail and the ion tail, which was really cool. Yeah, and you could see it visually from the darker skies. You could see both tails, and it was really incredible. It looked like it was just plunging toward the horizon.
Yeah. Oh, that's great. That's great. Anyone else before we transition to Sabella?
A very small thing about me watching the comet in my military service, in my wards, is that like I couldn't see the tail of the Halley comet. I tried to use my binoculars night visions for the repair store, because I made my military service in 1985,
Okay. And you had night vision binoculars?
Yes, because we had the Falkland or Malvinas War in 1982. In this place, they had a lot of military equipment for repair, and of course that I say, okay, I need a pair of night vision binoculars, like a goggles that you put. Imagine the size, the heavy thing that was in 1985, binoculars militaries for night vision, put like a helmet. And me, I was like an alien watching the sky, and in my guard that you think that they are not to see the sky. You need to be searching something because you are in a guard. And I remember that a young lieutenant came with another soldier to change the guard, and watching the sky like an alien or a robot. And he said, "What are you doing, soldier? Come on." Was it? Yes, I haven't done works, and I received, of course, a big explanation about be careful, with the guards. But I was crazy like today in this time watching the sky, because I needed to see the tail to the comet, but only I watched a more brilliant sky, all in green, with the grain and the noise of the electronic things in the 80s. Yeah.
But you saw it.
Yeah. No, sure. No. I was a little crazy in my military service. I know.
That's cool.
One thing I would like to say before we transition, I know the time is moving along, but I think it would be wrong if we let this conversation go without me quoting this, and I cannot find it anywhere in my book, although it's there somewhere, so I'm just going to quote it from memory. These are the most important words I've ever read about comets. It's from Leslie C. Peltier's Starlight Nights. If you haven't read Starlight Nights, turn off your computer, go to a store or a library, get it and read it. Here's the quote. Time has not lessened the age-old allure of the comets. In some ways, their mystery has only deepened with the years. At each return, a comet brings with it the questions which were asked when it was here before. And as it rounds the sun and backs away toward the long, slow night of its aphelion, it leaves behind with us those questions, still unanswered. To hunt a speck of moving haze may seem a strange pursuit. But even though we fail, the search is still rewarding. For no better way can we come face to face, night after night, with such a wealth of riches as old Cruces never dreamed of.
Wow.
Wow.
That's beautiful.
That's good memory.
That's, beautiful,
that's amazing
David.
memory.
And beautiful.
Wow. That's really nice.
I'm grateful to be here, David. It's a pleasure, really.
Yeah, that's really nice.
I can say again that David Levy is one of my heroes. Yeah, and it's incredible. I need to touch. It's real. I'm here.
Yeah, pinch yourself. Yeah.
Yeah. Yes.
Okay.
Sure.
Well, that was wonderful. I think we could go all night talking about comets and stories that we have to share about this. I know that it's the magnitude of how important comets have been to David. Really can't. It hasn't really been touched on in this conversation, but David and I are pretty good friends, and he said once during a conversation he thinks that comets had saved his life, and I agree with him. I know that he is. If you've read his book, you know that he's been through many highs, but also some very lows, and I think that it was comets that you know, it kept inspiring David to keep searching and to keep looking. And so I just wanted to say that, David, before we wound this up, because your story is a very, very, very special one. It's not just the discoveries. It's about what it did to turn your life around. So.
Well, thank you, Scotty. And even now, I do not expect in this age of computerized searches to ever find another comet, but I'm still searching because it's what I love to do, out there under the night sky with a telescope and searching just to see what there is. When you stand up in line at a telescope to look at something and you want to see the moon and you want to see the planets, that's a beautiful thing, and the sky will be a very good servant and show you what you want to see. The way I do it, the sky is the master. I have the telescope, and I just say, I'm going to go from here to there, and whatever you want to show me, I want to see it. And I let the sky decide what it wants to show me.
Very inspiring. Yeah.
Yeah, that's really nice.
Wonderful.
Well, I don't know. I was going to share some stuff, but it's probably not appropriate at this point. So I think we can move on. It's very nice.
We got more time in this show, so
I don't think nobody can top David.
That's beautiful. That was
much
really
as
nice.
Try.
That was really nice.
Thank you. All right. Okay. So we will, David, thank you again. This is a big honor. Thank you. And we have more comments from our chat that I'll read later, but I do want to transition over to Sabella. She's been up late, and she's recently back from space camp. I know she's excited. She has a presentation to show us, and I'm glad that her father reminded me that she was just recently back, so I'm glad that we were able to get her on. And Sabella, I'm going to turn it over to you.
Yay. So yeah, I went to space camp. It was really, really fun. And I just, let me share my screen so I can actually show you. Share. Okay. Can you guys see this? Okay.
Yep.
Yes, we can.
Yes. Can you see the little red thing?
Yep.
Yes.
We see it spinning around and
See that red comet. Yes.
Yep.
Okay. Just making sure.
Or electron, whatever it is.
So this is, it has like a bunch of pictures of what I did at space camp. And there is a lot more that we did, but there weren't like photographers around to take pictures of us. So only on the simulators, they took pictures of us, and then the rest my dad took. So yeah. So I was on Expedition 39. I don't really know why it starts in May, and there's not really like 39 weeks between May and the end of June. So I don't know where they get their numbers, but the airport there was amazing. They had like all this NASA stuff on the walls, and this is in Huntsville, by the way. Fairly small airport, but it was amazing. I definitely felt like I was in Rocket Town. And then, so I was put in Habitat 1, and then I was put on level 4, which is like an all-girls floor, and then room 19. It was a really fun room. I think all the rooms are designed the same. I am not sure. But yeah, we had lockers, and it was really cool. And the shapes of the habitats were very interesting. They were like circular inside. So here's me trying on some of the stuff. This picture to the left here is all the stuff that we got. Yeah, they just had a lot of cool stuff there, and a lot of stuff I would need to use on the trip, like their t-shirts and stuff. And then there's my flight suit. I was gonna wear my flight suit to graduation, but we got the size really big, So after the graduation was over and it was like our last day of space camp, we went to go get me a new one that was actually an extra size bigger, because I plan to go next year and I want to wear it next year.
And you'll certainly grow. So
Yes. And then this is kind of what the room looks like. This is like half of the room. This is my bed back here. Where she's sitting, there's like a wall because there's a bench right here. So I put my head behind the wall, and then I put like some towels and some blankets on the sides, and it was just my own little room. So, and then I had 3 other roommates, and it was really, really fun to talk with them. So this is where we went into to get all signed up and make sure that they had my picture just in case if anything happened. I think that's the guy who took the picture. I do not remember. And then, so this is where we wait for our team leaders to come pick us up. So we're just all waiting there. And this is at the bottom floor. And then here's some cool pictures. This is the Saturn I rocket, I believe. Yeah. It was really tall. It's to scale. It's not an actual rocket, but it's just a model. These things are huge though. Then there's this really cool sign in the museum that says Rocket City. So I had to have Dad take a picture of that because that's what it's called. And then this is the big shuttle. It's Pathfinder, called Pathfinder. It never actually went into space. It was just a simulator of what the real things would be. And then this is one of the missiles, I believe, Werner von Braun made, I think. I'm pretty sure.
It's like a V2.
Yes, I think that's what it's called. Then I was put in a team with other kids my age, and I got Cepheus. Let me adjust my microphone. There we go. And we had 12 kids in our group, 4 boys and 8 girls, surprisingly. So, and the patch was really cool. And my mom's gonna help me sew it on to my uniform thing.
Very cool.
And then, so this is the chair where it makes you feel like you're doing a spacewalk, like with one of the jetpacks. I look really tired. It was like 8 or 9 o'clock at night when we did this. But it was really fun. Someone like swung us around and we had to lean forward in order to move forward. And it just felt really fun. And we got to fix things on like this metal bar thing here. They were like switches, and we had to use like a wrench to tighten things. And then, so this thing, I forget what it's called, I'm sorry. This thing makes you feel like you're spinning out of control in space, except with gravity this time.
I've been in one of those. They're so much fun.
Yeah. So you go upside down, all around. That's Logan. He was one of our team leaders. So, and while we were on the ride, they asked us questions like, what did we have to eat? What did we eat? Or like, what's your favorite color? Just because, so that way we would focus more on the questions rather than having the thought of throwing up.
Right.
But thankfully, if you put your hands in the right spot, you actually won't throw up, but just in case they ask you questions. And then, so this is the 1/6 gravity chair. It makes you feel like you're walking on the moon. This was really, really fun. And it was very hard to move forward. Like it took us so long to get across and back. And funny story, they didn't actually take a picture of me doing this. This is not actually me. It looks like me. So just one of my friends. But you had to like jump forward, try running across, and then do like a side jump. I don't know what you would call that, but yeah. And then so we were put on a mission. Wasn't a real mission, obviously, but it was a fake mission. And so I was mission 18 commander. There were 2 missions for our team, 18 and mission 18 and mission 19. I was assigned as commander for the first mission, which was when we started. We were already on the moon base. This is obviously not on the moon, but it's like supposed to represent like a moon base thing. This is my desk, and we had to do experiments. We had like a day of training, and all went well. It was really difficult at times because I had to fly the command module back home and like 50 million buttons. And then this is actually a real Saturn V, 363 feet tall, in this case long because they laid it on its side. And it shows it in its stages, and it's literally like a real Saturn V. I don't know if there's things inside it, but it didn't go into space, but it was, I honestly forget what this one was used for. It was just like a practice with like towing it and moving it around, or if they simulated the inside. And then this was my graduation. They had the flags behind us. You can only see the aviation challenge. But they had like the space camp flags. Then here's my certificate. I also got some like wings to pin on to my, I'm forgetting the name of it. I'm just gonna call it uniform because I keep forgetting. But it was really fun. It was the only time that we got to take our masks off inside, so it felt good. And then I was really sad to go back home because I really wanted to stay in touch with a lot of the friends that I met, but sadly, like almost none of them had phones, so I only got contacts of 2 other kids. But hopefully we can meet again one day. And then the sun was seeping through the clouds.
Beautiful.
Oh my, that was a huge voice crack. But it's pretty, yes.
Very beautiful.
And then here's a bonus. Where is the shuttle? So the shuttle was like this when we went. It was not on top. It was actually removed for renovation. And this red iron rusty cage that you see down here is actually the shuttle. It's the skeleton of the shuttle.
Oh, wow.
Yeah, they took the shuttle down earlier in the year. I think it was January. Then these are just pictures of it being lifted off. They had to get a crane and everything. I'm still curious on how they took the wings off because they lifted it off without the wings. So, and yeah.
Wonderful. Now, I'm one of the things I want to point out. We are now living in a time where there are Branson has just gone up with Virgin Galactic. Again, another indication that more and more of us will be going into space. And Sabella, I think that you probably are living in a generation where you're going to know, if you don't do it yourself, okay, you're going to know people, you're going to have friends that have gone into space. This is, we now live, I've said it before, but we have people in space 24/7, 365 days a year. We have spacecraft all over the solar system. We don't just live on Earth. We don't just explore, our world. A lot of people just kind of think of ourselves as humans that are inhabitants of the Earth, but we inhabit space. And so you are certainly going to be of that generation Your kids, Sabella, I think it will become commonplace for your friends, your kids, your grandkids will have visited space, and so I think that you've taken important first steps to understand what it's going to be like in the space environment, some of the challenges of space, and what are your long-term goals for doing this? I know you had a great time at Space Camp, and I know it was fun, but yeah, what do you hope to accomplish in your adult life?
Yeah, so I hope to have like a job that has at least something involved with NASA, whether it's like helping design the rockets, or even just like designing new spacesuits, or even going into space. That would be amazing. But I know right now there's still a lot of risks to it. But yeah, I just want to have something to do with NASA.
Yeah.
Or space in general. There might be like a new space program when I like in my 20s and 30s.
Sure. Well, Sabella, thank you for coming on, and congratulations on graduating from Space Camp. So thanks again. We're going to take about a 10-minute break, so you can stretch your legs and get a coffee, get a sandwich, and then we'll come back. Libby is not here with us today, but she did send me a video from her from Space Camp as well. It's a short video, so I'll be playing that in a few minutes. So, but we'll be back in about 10.
Oh, it's great, Sabella.
People have been hunting for sun-grazing comets for well over 100 years. But up to 1979, we only knew of less than a dozen. As of 2020, we have seen around 4,000 sun-grazers. Why did the number increase? The answer lies along the route most sun-grazers follow. In the late 1800s, Heinrich Kreutz observed that a few recent comets traveling near the sun appeared to follow the same orbit. On this Kreutz sun-grazer path, as we've come to call it, it takes the comet several hundred years to complete one loop around the sun. While there are other orbits of sun-grazers, Kreutz comets are the most common. All of the comets in this orbit came from a single comet that fell apart near the sun thousands of years ago. As the comet moved closer to the sun, the ice binding it together evaporated, breaking it into smaller pieces that the sun's gravity pulled apart. Every time a comet comes around the Kreutz path, this can happen again, resulting in a new generation of comets. It might sound like this would clutter the solar system full of comets, but that's not the case. Most of the new comets are small enough that they become completely vaporized as they approach the sun. There are more comets observed in the last few decades, not because there are more in the solar system, but because we have better ways to see them when they are close to the sun. Spotting a sun-grazer from the ground is almost impossible because of the blinding sunlight. Now, spacecraft uniquely designed to look at the sun can block the brightest sunlight, making the job a lot easier. Since the joint ESA-NASA mission SOHO launched in 1995, it has shown us thousands more comets than any tool before it. With SOHO, we can now see the smaller, fainter comets close to the sun, just long enough to add them to our list of sun-grazers before they vaporize. The spacecraft's data is available online, so now anyone can discover a comet. Roughly 95% of these comets have been found by amateur astronomers. SOHO isn't the only sun-observing spacecraft to have surprised us with beautiful images of comets. NASA's Solar Dynamics Observatory has spotted sun-grazers too, though less frequently than SOHO. Now that we can observe comets better than ever, who knows? Maybe you will spot the next sun-grazer.
In the interest of filling dead airspace, who else is still on and just turned off their camera?
Hey, Molly, I'm here.
How are you doing?
Good, good. How are you? You got your scope set up yet?
Not yet. The telescope room is the last room I had to unpack because I had to make space in the rest of the house to move the other stuff out of it that a lot of my boxes weren't labeled very well, unfortunately. So several ended up in there that didn't belong in there, but I had to make room to move those out of that room before I could start to move around my telescope stuff. So I've got some stuff staged in the house and in the garage ready to move outside. But it's either been blazing hot or dumping rain for the last 2 weeks. So they have not gone up yet, but I have all of the bits and pieces to put them together. I just need to find time to do that, and also find time to do it when the weather is supportive.
Yeah, it's kind of like one of those jigsaw puzzle things where you kind of move things and you have only one slot. You have to kind of move it around.
That's exactly what I'm having to do. Yeah, it's like gridlock.
That game. Yeah, exactly. Slide things around, but at least you got everything there. It's good.
Yes.
And it will take time. Yeah.
It looks like I've got everything, and I'm more unpacked than it looks like I am. There's still a lot of boxes laying around, but it's kind of the last bits and pieces that I haven't figured out where to put yet. So we're getting there.
Cool. That's great. Have you you haven't traveled since then, right? You were saying, or are you still on the go, or are you
no, I haven't gone on any trips. I am planning on going to, let's see what's coming up. Black Forest Star Party is on my list to go to, but that's not until September, if I recall.
The Nebraska one is pretty close by where you are now, right?
I mean, I guess so. Yeah.
Well, I'm thinking it's around a 13-hour trip.
Oh, that's
you.
True.
Yeah, it's 15 for me.
Okay.
Yeah.
Thought it was close.
I was considering going to that for at least, if nothing else, pick a good night, go overnight, and see what these dark skies are about. But as you know, Okie-Tex is the ultimate goal, and I'm shooting for a I don't know if it's as well known, but it's definitely a lofty target. I'm hoping to image Einstein's cross.
Oh, that's on my list as well. Yeah. Once I get my my long focal length stuff stable enough to, well, I think I have crossed the threshold to be able to probably do that at a dark sky site, because one of the sometime within the last year when I went out to the dark sky site and I got out there and set up my gear and everything worked right off the bat. So I've gotten my procedure down well enough now that I'm facing fewer and fewer issues when I actually get out to the field. And a lot of that is from moving my entire setups. Like I have all my wires, all of my cables are bundled, and each telescope rig has its own power box, and then that gets plugged into the extension cable. And then the USB cables all get plugged into one hub into one of my two computers. And so what I set up at home is now perfectly repeatable when I go out to a dark sky site. So that really lessens the amount of setup time when I go out to a dark sky site. And so the next time I go to the Texas Star Party, I'm well situated to be able to start imaging the first night instead of the second night, as has been my tradition in the past. Having nicer mounts is a big part of why that's working, as opposed to some of my previous mounts not working as well.
Oh yeah, the mounts are the centerpiece of reliability. You absolutely need to make sure that mount is good. Yeah.
Between that and a good controller, I've had the a G11 low spin demount, which I guess is supposed to be legendary for what it can do. I had its old drivers on it and it drifted terribly. I had a friend help me put new motors on it, and he had a new control computer for it. And now the mount is great. You know, I connect it with Sky Safari. I put my finger on the screen. If I, of course, good or good alignment, usually 3 stars or so, and then I say go here, and it goes there.
Yeah.
And then
That's
I can,
nice.
yep, I can adjust it. I adjust it a little bit as I go. Say, you know, make this an alignment point. So especially if I shoot a particular part of the sky, it's just tap the button. That's how I intend to get to Einstein's cross, is to do my star alignment in the area so that it's very accurate there. And then once I've tested a few objects, if they show up in the center nearby, then I'm going to go for it and then try and get it into the center. And
why not plate solve?
Well,
I don't even have a good alignment model. I just plate solve my way to the target.
well, I don't know if I've the old stuff that I've got. I don't know if I've got a plate solver thing in it. I do have EOS Backyard, the later version that I'd be using with the
oh yeah, I think they have a
camera
plate
itself.
solver in Backyard EOS now. I think
Okay, if they have one,
or if
then
they don't, you can set up SharpCap to folder monitor, so you can take DSLR shots, and then SharpCap can read in the shots saved to your computer, and it has a
and
plate
then
solver.
solve.
And Sequence Generator Pro will also work with
It's Libby.
Nikon and
It's
Canon
Libby.
cameras. Okay, I think
Yep.
we got Libby's video now.
Yeah, we'll talk more later on it.
Yeah.
5 days, and I'm so excited to be here after 8 long hours in the car with my mom, passing through Memphis and all that stuff. It was fun to be on the road, and now I'm finally here. Tomorrow morning I'll be checking in really bright and early. I'm so glad to meet new people. Sadly, I won't be able to make it on the star party because I don't have a computer with me. I can't really bring a computer to camp because there is no Wi-Fi. But I did make this video just so I could share with you guys what space camp looks like. And right behind me is Habitat 1, which is just supposed to look like the International Space Station. So inside, it is supposed to look like the International Space Station. And this is where I'll be staying with a couple of friends and get to learn about space. And right around me, we have Pathfinder, which is the wooden model to help measure. And we also have some more rockets, which I'm so excited to see over the next 5 days here after traveling in the road. But hopefully, after I get back, I'll be able to join back onto the star party. And I'll get to see you guys soon. Have fun. Have fun on the star party. I'll see you guys soon. I'll make sure to share all the experience.
Well, that was Libby and the Stars out and also in Huntsville and at Space Camp. So it's great to have her make a quick video for us. While she was there, she called me over the weekend and showed me one of the Saturn V mocked up rockets that's in the I guess maybe they call it the rocket park or the rocket yard or whatever, but it is the city of rockets. Huntsville is a place I've not been to, a place I definitely want to go see.
What's that? Rocket Garden, I think it's called.
Rocket Garden. That's right. That's right. So yeah, I would have been, oh my goodness, as a boy attending something like that, I definitely would have been in heaven. But up next here is Molly Wakeling. Molly mentioned earlier while we were having our discussion rounds with David Levy about comets, she mentioned that she had collected some of her comet images. So I'm going to turn that over to you, Molly.
Yeah, sorry, I had to switch screens here a little bit.
Okay.
Yeah, okay. Let me go ahead and share my screen here. Get started. Yeah, so since we're talking about comets, I figured I would make tonight's Astronomolly's Universe segment about Comet Neowise and talk about a little more about what it is. And I mean, a lot of us got a chance to see it. And we know about comets in general, but this would be a good opportunity to learn about Neowise in particular. Yeah, okay. So it is a long period comet. So there are some comets that can come from closer parts of the solar system and come by on a much higher frequency, like within a lifetime or maybe 2 lifetimes or something. But this comet comes around a lot less often than that. It's the brightest northern hemisphere comet since Hale-Bopp in '97. There was a bright comet in the southern hemisphere, I think, since I started doing astrophotography, and I was sad to miss it. I don't remember what the name of the comet was, but our southern hemisphere friends got a nice show. And Neowise is not the actual name of the comet. Comets are named for the discoverer of the comet most of the time, and sometimes that's an individual, and sometimes that is a survey. So in this case, it was a survey by the Wide Field Infrared Survey Explorer, which is a space telescope. And the actual name of the comet is Comet C/2020 F3 Neowise, which indicates that it was observed in 2020 is when it was discovered. And they have some kind of incremental naming system that I didn't go research for this talk. But yeah, so Neowise is kind of the short name, but Neowise is really the kind of particular mission of the WISE Space Telescope. And,
might that be near Earth object?
Yeah, probably. Although in this one, you know, the actual comet, actually, yeah, it did come within some distance of Earth, but yeah. So where was it when it swung by? This is a map of the sky showing its orbit from Earth's perspective. So you can see that in this part of it, it kind of had this really high frequency that moved really rapidly, and that's when it was closer to us. So it's moving a lot faster through the night sky, and you can see its path overlaid over a map of the sky here and a map of the Milky Way. So when it was brighter, unfortunately, it was mostly up during the daytime, since it's kind of our winter sky. Over in this region, we have Orion and the winter Milky Way and Leo. So when it was really bright, it was up during the daytime and none of us could see it, because again, this was in July, if you recall. So the winter sky is up during the daytime. And then when we saw it at night, it was a lot dimmer than it really got in magnitude, but we just couldn't see it. So, but it was still got plenty bright enough for us to be able to see even during the nighttime hours, or the early morning or early evening, as it were. It's I couldn't find a picture of its full orbit, but you can kind of get a sense for how highly elliptical this orbit is. It came in pretty close to the sun here, inside of the orbit of Mercury, and then made its way back out of the solar system. And as far as where is it now, there's a website that tracks comets and kind of shows a cool 3D viewer that you can tilt and move around. It's actually not as far out as you might think it is. It's still not, despite the fact that it was almost a year ago now that we saw it here near the Earth, it's still only out between the orbit of Mars and Jupiter. Because once it gets on the long side of its orbit, it's traveling slower from our perspective, and I think slower in general because it's not close to the sun here. But you can see where it swung by the Earth and is on its way back out into the outer reaches of the solar system. These are numbers that I pulled last night. It's currently 459 million miles away from us and is traveling. The numbers are printed twice here. They messed up their website code a little bit. It was traveling at 27.5 miles per second, which is
second.
Fast. Wow. Crazy fast. But then again, the solar system is very large. Yeah. So despite traveling that fast, it's only got out between the orbit of Mars and Jupiter a year ago, from a year ago. So space is big. Space is big. All right, so some fast facts. Its orbital period is approximately 6,700 years. So that's roughly how long it will take to make a complete orbit and come back around to Earth, or to at least to around the sun again. So that's why it's called a long period comet, because it's going to be a real long time before we see it again. At its furthest distance from the sun, aphelion, it's at 710 astronomical units. So way out past the planets of the solar system. And at perihelion, it's at 0.295 astronomical units. In case you're unfamiliar with the unit of astronomical units, that's the distance from the Earth to the sun. And we kind of use it as a standard unit for measuring distances within the solar system-ish type area. So it comes pretty close to the sun, a fraction of the distance from the Earth to the sun. It was discovered on March 27th, 2020, again by the WISE telescope out in space. At its brightest, it was observed, or at least as brightest that we observed here from Earth, it was observed as being magnitude +1, which is quite bright. And the actual physical size of the comet has been determined to be about 3 miles wide. So that's very small on an astronomical scale, kind of large if you imagine a chunk of rock 3 miles wide hurtling through space at 27.5 miles per second.
Yeah, get out of the way.
Yeah. And a cool fact that I found was, so comets they have a lot of water, and that's a lot of what is oblating off of them when they're swinging around the sun and being heated by the sun's energy. In this case, the water content of this 3 mile wide comet is 13 million Olympic swimming pools. Which is a really difficult amount of water to imagine. I didn't have time to go through and compare, like, how does that compare to like the Pacific Ocean? It's probably still a fraction of that, but it's a lot of water. And there's some theory that maybe at least some of the water that's on Earth was kind of seeded by being struck by asteroids or comets that have high water content. So what are the parts and pieces of a comet? So at the center is the actual rock, which is the nucleus, which usually, like, you know, especially with our amateur gear, you're not going to be able to see that from within the bright glowing coma and kind of the overall section of it that's referred to as the head, apparently. This kind of bright area here. So the coma, as you can see in this illustration, is actually a lot larger, or typically a lot larger than the actual rock itself. And then off of that, you have the dust tail, which is kind of the, so these comets, they're getting close to the sun, and so they're getting a lot more energy on their surface than they receive way out in like the Oort cloud or the Kuiper belt. And so the solar wind is removing some of the surface material, which is this dust trail. And then there's the ion trail, which has to do with gases on the comet that are being ionized by the sun's energy. And sometimes, depending on where the comet is in relation to the sun, the dust tail and the ion tail are in the same place. Because the dust tail, let's see, I'm going to get this backwards. One of the tails is exactly perpendicular to the sun, probably the ion tail. And then the dust tail, I think, has some angular momentum component to it, so it can kind of curve off. And this is one of my photos that I took with a 200mm camera lens. And you can see that the dust tail is a lot brighter, but you can see the ion tail up over here heading off in a slightly different direction by the time this picture was taken. So I always like to include a slide on what things look like in other wavelengths, because we, as amateur astronomers, we're always thinking of optical wavelengths, but a lot of things out in space can sometimes glow even more prominently on wavelengths that we can't see, such as infrared or X-ray or ultraviolet. In the case of comets, there's not really a lot of non-optical light emitted, because it's really just this energy of the sun that's applying energy to the comet, which is typically going to be in the optical range. But here's a couple of interesting ways to look at the comet. So the picture on the graph on the left is, and I realized I have my mouse on the wrong screen for the whole last slide. The image on the left is showing light reflected and emitted at the sodium D line. So if you're familiar at all with like high pressure sodium city lights, for instance, there's a particular wavelength that they glow at, and it's actually two very narrowly spaced wavelengths at 589 nanometers, which is in the yellow region. And the left part of this image is looking off band, so not looking at those exact wavelengths, looking at reflected sodium wavelength light. And the picture on the right is looking at emitted sodium wavelength light. So in this case, the emitted light is the comet has some sodium in it, and that sodium is being energized by the sun's energy and emitting light on a particular wavelength that we can see. And this plot is kind of showing the different concentrations of that, and it's just kind of cool. So it's still optical, but at a very particular wavelength, kind of like narrowband imaging with hydrogen and sulfur or oxygen. In this case, we're looking at sodium. And the picture on the right is the discovery image that was taken by the NEOWISE project. So this is actually 3 images across 3, I think it's all in the same night. It's within a couple hours of each other. And so they just overlaid it to show that the comet is moving over the course of that. But this is an infrared image kind of showing its glow here. And it was magnitude 18 when it was discovered by the telescope. So of course this image is quite grainy because it was quite dim. So magnitude 18 is a little bit outside of what most amateur equipment can grab. But there are still a number of comets that are discovered by amateurs, which is evidenced by when you have a telescope, or when you have a comet come through that has the name of a person, then it was discovered by a person and not a big project. So amateurs still do discover comets because surveys can't pick up quite everything. So of course, Comet NEOWISE is long gone now. It's currently, at the distance that it's at from us and from the sun, more importantly, it's at 24.57 magnitude, which is definitely outside of what I can image. That's pretty far outside of what I think pretty much any amateur telescope can grab. I think some of the professional ones can grab magnitudes that dim. Hubble certainly can, but this is that shot here that I took from the backyard of an apartment complex in the wee hours of the morning, looking out north of the San Francisco Bay Area. And that was my first glimpse of the comet, which was so exciting to see it naked eye. Like that was the first time I saw a comet naked eye. It was extremely cool.
Oh, that's great.
So that Comet NEOWISE is long gone, but pay attention for the next comet. A lot of times you'll hear a news article saying, this comet may get bright, because a lot of times we don't know. We know its orbit pretty decently, but it depends, how bright it is will depend on whether it breaks up when it goes by the sun, how much gas and dust it's emitting. There's a lot of different factors, and we don't always know their orbits very precisely, at least, especially when they're first coming into our view. So sometimes a comet is promised to be bright and ends up being pretty dim, and then it's a bit of a disappointment, but it's always worth kind of keeping an eye on the news so that you can catch the next bright comet.
Yes.
And this is probably the best image that I got of it. This is on the camping trip that I went with my parents and my grandparents up in northeastern Washington. It was quite dark up there. I estimate about Bortle 2. And this was, so it's not, it doesn't, at that latitude up at 49 or 50 degrees north, it doesn't get fully dark during the summertime. So this glow you're seeing in the background is largely just because twilight doesn't really end. It's kind of in astronomical twilight most of the night. But you can see even by this point, which was a couple of days after the previous image I showed, and this is a much wider field of view, you can really see the ion tail being at a different angles than the dust tail, which is kind of curving off, which is really cool. and got a nice foreground of some trees and some red flashlight here reflecting off the trees. But my parents and my grandma and grandpa had a very nice time being able to see that naked eye from a nice dark sky site, and we're just kind of thought it was fun that I was taking pictures.
And what a treat it was during the pandemic, you know?
Yes, yeah, and that camping trip was kind of the first time I got out of town after the pandemic started. I drove up to Washington. That's when I bought my my new camper, which is, I guess, almost a year old now. But we went camping that weekend, and then I bought my camper. So
awesome. That's
I really like those pictures, Molly, because they really capture the feeling, the moment of actually seeing that in a, it nicely framed. You got the Comet Neowise, for the first time. Both the ones in the Bay Area and of course in Washington, seeing that between the trees, it's really nice. Yeah, I can imagine what it was like.
Yeah, and I think seeing it with trees in the foreground kind of makes it gives you a sense of scale of how far out the tail goes. And of course my camera could see a little more of that than my eye could, because I was taking a couple second long exposures there. But you could still see it naked eye, and it gives you a sense of scale for how large these things appear on the sky and how long their tails must be for the distance they're at from us, which is, relatively close, but still not in the actual sky, right? That tail is some number of many miles long.
Very cool.
Yeah, beautiful.
Thank you.
Beautiful. Okay. Well, Deepti Gautam is on with us from Nepal, and she will be. Her talk is going to be about comets. So, Deepti, you're on.
Hello, Scott, and hello, everyone. Today, I'm talking about the comets. And first of all, from the short introduction, and a comet is the ice, a small solar system body when passing close to the sun, warm up and being to release gases, and a process that is called outgassing. And this produces a visible atmosphere or coma, and sometimes also tail. And comets are frozen leftover from the formation of the solar system, composed of dust, rocks, and ices, and they range from a few miles to tens of miles wide. But as they orbit closer to the sun, they heat up and spew gases and dust into a glowing head that can be larger than a planet. But dust particles combine to form icy rocks that join together under the form of force of gravity, and high-speed collisions result in loosely bounded collection of fused rock and soil ice. And when a comet passes through the inner solar system, its ice warms and releasing a trail of gas and dust. And coming being a mixture of ice and dust, and end up losing their ice and gas each time they orbit around the sun, and they come to the Kuiper belt and Oort cloud. And after around 500 passes, they lose most of their ice and gas content and eventually turn into something close to an asteroid. And comet also have a big influence when they collide with Earth. While collisions between Earth and comets are currently extremely rare, millions of years ago it was more common. Some scientists argue that colliding comets early in Earth's development contributed much of Earth's water. And collision with comets and other stuff from space have been responsible for huge landmark in our planet history and global shifts in climate, and the creation of our moon, and the resolving of our deepest geology and extensions of species, etc. And I have some presentation. Let me share. All comments, and I have short video clips. Sorry,
I like snowy dirt balls.
Pretty good presentation.
And I have I have found one
right to the point.
short poem that is from the Robert Longley and about the comets. And star at night they twinkle after and burning bright, each a source of wonder, standing bright amidst the night. We pay them small attention, for they are always there. We go about our business with but a single care. But then there are comets, bright and blazing past. Everyone takes notice, even if they do not last. If worse people remember the dramatic burning light, they stand out on the landscape and brighten up the night. Thank you. This was for today.
Very good. I hope David was still listening to that because that was a great poem. Thank you. Thank you very much, Deepti. Well, we look forward to you being back on the next Global Star Party. Our next event will be on July 20th. And of course, that is the anniversary of the moon landing. And it's also the anniversary, I think, of the Viking 1 lander on Mars, something like that. So there's lots to talk about. And it's always great to get your perspective. So thanks for putting that on. Well, up next is Jason Guenzel. Jason is really one of the top astrophotographers around today, and I'm constantly blown away and amazed by his images. And I have seen a lot of astrophotography over the years by amateur astronomers. Often studying, the best images possible from amateur astronomers for use in catalogs and just for my own inspiration, But I'm constantly, when I want to show some of the best stuff done today, I often turn to Jason's work. So, Jason, thanks for coming on again.
Yeah, and thanks for having me. Thanks for the compliments. I don't know. After you see my comet images, maybe we'll talk again. We'll talk again. But
comets are tricky. They're tricky to photograph.
Yeah, they are. But I was largely quiet during that, or completely quiet during that first segment, because I figured I'd get my chance to talk here about my experiences with comets. But I have largely the same experiences that a lot of people on the panel do, probably a lot of the audience too. I'm of the age where the only bright visible comets that I've experienced were Hale-Bopp and then now Neowise last year, but there seemed to have been a long drought of period of time where there was not really any visible comets available to us. So it's exciting to see finally getting some action on that front. So I have a series of images I'll show here of just comets I've taken over the years. I started astrophotography roughly a decade ago and really tried a couple early on comet shots. Never got too great of initial result, but over time I've gotten a little bit better at capturing them and processing them. And then Neowise, I really jumped on that opportunity, as most people did, to try to get the most they could out of it. Unfortunately, the weather is always a factor, and struggle with that a bit in the Neowise time frame. But I will share my screen here and start. Make sure that this is the screen I want. Okay, can you see a screen?
Yes. See a bunch of thumbnails.
Yes, we can.
Yes. So here we go. I'm going to start in chronological order. And this is kind of a cool one because this one was not captured by me. This was actually taken by my father. This is Hale-Bopp in 1997, taken from the shore of Maui, actually from a hotel balcony looking out over the ocean. And that's Hale-Bopp up there in the sky. So he took this, like I said, with a film camera, Canon AE1. And all these years later, over 20 years later, we found the box of negatives. And I was looking through them, and I noticed that, or he said that he had some shots of this. So I was looking specifically for these shots, but I ended up having one of Neowise. So I took that negative and I held it up against an overcast sky, and I took my modern digital camera and I just snapped a picture of the negative, and then took it into Photoshop and inverted it, and voila, we have we have a picture of Comet Hale-Bopp that was taken, I believe, in early or late March of 1997. So it's kind of a collaboration with my dad. Kind of cool.
Beautiful.
All right, and then I got an SCT telescope in 2013, and within a couple months I was already trying to take pictures off the back of it. So I knew of this comet in the sky. It was Comet Ison. Its nomenclature was C/2012 S1 Ison. This comet, I don't know if anybody remembers this, but this was one that flew too close to the sun and ended up breaking up in its path, around the sun, and came out the other side in a million pieces, and it was no more. But it was promised to be a pretty bright comet if it had survived. This shot I took before it rounded the sun, and I just took a short string of exposures through my 8-inch SCT and stacked them up. And then it's tracked on the head of the comet, so you can begin to see the tail behind it, and the stars stretch out into streaks once you do that. That was kind of my first comet attempt.
That was a nice green comet there. I'm reading about it now. It says if a comet contains carbon, nitrogen, and carbon-carbon bonds, the sun's ultraviolet light will excite the electrons inside of it, causing them to emit a green glow when they drop down in energy.
Yeah, so you can tell a lot about a comet, by its color signature, and many times, and this is the case most often when they get close to the sun, they will start to grow they will start to glow green around the nucleus specifically, and that's that that carbon emission that you talked about, Scott. I don't know the exact chemical properties that give rise to it, but it's a pretty common thing to see in comets. And that's a great segue into my next image, which is a wide field shot. Now this spans all the way between the Pleiades, which is on the left, and the California Nebula on the right. This was taken with a DSLR, and this smudge here is actually a comet. You can see my mouse.
Wow.
But what's unique about this comet, it's very small in this field of view because the field of view is pretty big.
Huge. Oh, yeah.
But this comet was growing a bright blue tail, and there were a lot of shots of this taken during this time frame. I took this picture in 2018, and this comet nucleus was rotating very fast and creating a spiral in the tail. So if you look at detailed, longer focal length images of this comet specifically, it was a really structured and complex, almost helical tail coming off the back of this. And it was bright blue because of the presence of carbon monoxide. Like I said before, those different elements give rise to different colors within the comet. But this one was pretty unique. You don't often see a bright blue tail, and I thought it framed nicely against the the blue of the Pleiades here.
Yes.
Yeah. Probably one of the better wide field comet images I've seen. So.
Yep.
Yeah.
Thanks. So we didn't talk too much in this whole comet discussion about our interstellar visitors. So we've had 2 within the last few years discovered, and those are the first 2 that we have known about. I don't think there's been one since this one I have pictured. And this was discovered in 2019 with the name Borisov, and this is an infinite period comet, which means it originated outside our solar system, passed through the plane of our solar system, and went back out into interstellar space, never to be seen again. Unlike Oumuamua, which was the first one, which didn't sport much of a tail, this one did emit a tail. So they were able to research a little bit more about the composition. And I was working really hard to capture this. It was an extraordinarily dim in the telescope, and I didn't see anything in my single pictures or anything. And after careful stacking and pulling some tricks on centering the comet in the stacking routine, I was able to at least show a fuzzy blob. But that is my only picture of a interstellar comet.
It's very rare.
I don't think many people tried this because it never reached, a brightness that was very accessible to amateur telescopes. But I wanted it bad enough where I went through the steps to make it happen. All right, and this is a time-lapse video. Now we're stepping forward to 2019 Comet Atlas, which I actually captured in April of last year, 2020. But this comet was discovered in 2019. And this time lapse just shows the movement of the comet over a couple-hour time period. Let's see if this will play for you.
Oh, this is cool.
And I've got the field rotating too, but this gives you an idea of the movement of a comet through the sky over a period of time. So again, this is all sequential sub-exposures same night, and then placed together in video format. So
that's awesome.
Yeah,
get an
I love
idea
that.
of how fast those things move through the sky. So if you sit there and you take a picture, and then you take a picture 2 hours later, it's going to be a significant distance away from where it started, and that's what presents the challenge to comet photography and taking these images, because you've got not only the stars moving across the sky, But you've also got this comet moving relative to the stars, so you need to handle them separately if you want to stack them to increase the signal to noise and make the tail more visible. And that's what I did in this next shot, which is the same comet. You can see then once you stack the image separately for the stars and for the comet to keep everything, the stacking in the right place geometrically on top of each other.
Yeah, it looks jewel-like. It's really
yeah,
beautiful.
you begin to see them. You can see the detail, the nucleus, the colors, and you can see the tail then extending away. This one just had that dust tail, not an ion tail like the Comet Neowise had. I believe now I'll step into, oh no, this is so I took a few pictures of that Comet Atlas. Here's just another one. All right, so we step forward now 3 months into this exact day 1 year ago. This is Comet Neowise up here in the sky. And again, I set a camera up on a fixed tripod and just time lapsed this. So I'll let this play.
Wow.
And so this is, as the sun is setting, I've got the exposures rolling. And as the sky darkens, then you know, the tail of the comet begins to bloom. You can see it. And I'm just playing it forward and backwards here, boomeranging it a bit, and then zooming in just so you can see that.
Very cool.
Ah, well done. Well done. That's really,
yeah, I like that.
Really captured it nice. Very,
Yeah, so
very
this was, well, I think Adrian might be the only person that knows this location, but this was at Kensington Metro Park.
Yep. Yeah, this Metro Park is known more for wildlife and
birds,
birds, but yeah, this was the first time I saw a well done image. I think at the time I only saw the image, not the time lapse that you have, but yeah, it's yeah, you tell them they allowed you to stay a little later because normally they close the park at dark, but
yeah,
you were given the
I didn't tell him, I just stayed.
No, you have too much luck with the clouds.
It was an experience. You know, I brought my daughter out there with me, and you know, we got to watch this thing kind of just appear out of the dusk. And
what was your daughter's reaction to this?
Oh yeah, she like, I mean, you know, at first I'm like, do you see it? You see it? I don't see anything, you know, but yeah, I mean, after once she saw it, it was a good experience for her. So I was glad to be able to do that. And you know, this kind of hooked me on it. Up until this point, it was a morning comet, if you remember.
Yeah.
Actually, if you're far enough north, it was circumpolar, which means it never set. But I was right far enough north to where it just kind of kissed the horizon and then begins to rise again in the dawn. And but it moves through the sky, you know, over time. And before these dates, before, you know, mid-July, it was better to view it in the morning. And then as it became later in July, it became more visible in the evening. And so once I got this shot and got a little bit of practice in, I got bound and determined to get a better shot of it. So this was 3 days later. I set up again with a little bit longer focal length, trying to get a view of this thing. And lo and behold, I ran it right into the roof of the house. So I
wow.
Replanned this one and got out there in a different position and a little bit earlier. And
holy smokes, look at that.
Shot this sequence. Now this was on the 17th, so a few days later. And now you can actually, even in the still, you can see the ion tail, right? That kind of sprouted within those last few days. And the unfortunate thing for me now is I was shooting through all these thin clouds gives a cool look to the video, but when you try to stack the images after, it turns into a nightmare. But I think this shot, or this is my favorite sequence from the Neowise time frame, just because you get this good view of the ion tail. Almost looks like real time, right? Because you're seeing the time lapse.
Yeah.
Just in these single frames.
Yeah, it's so hard to imagine when you're observing these things through a telescope or photographing them that the actual comet is tiny compared to what you are photographing, you know, and you think that, oh yeah, I've got the head of the comet, but no, the brightest part of it is still this gas and dust, and you probably couldn't even resolve the actual comet itself, you know, because they're just a few miles across.
Stay tuned.
Stay tuned. Okay.
This I'm backing up one, but this is the stack of that video I just showed, where I stacked the comet and the stars separately. This line here is the roof of the house, which got into the field of view a little bit, but sorry. But I had a lot of problems in post-processing this because of the clouds, as I said. You know, created streaking and color issues through the whole image, but at least you get a sense of the detail that's available once you stack these images. You can see, you know, striations in the dust tail itself, and also in the ion tail. So as Molly was saying, the ion tail is a stream of charged particles that always points away from the sun, whereas the dust tail follows the orbital motion of the comet itself and kind of plumes out. So you get these two different directions depending on the way the comet's moving. It can be completely opposite in direction, which is strange. Yeah, so this is now with my 8-inch SCT zoomed in on the head, just the head of the comet. So
Wow.
it's a super, you know, 1500 millimeter focal length shot of the head. And you can start to see the beginnings of the ion tail and the striations and the dust coming off the nucleus of the comet.
That's one of the finest comet shots I've seen. Very nice.
And I did this long focal length thing a couple times trying to get more detail. That was a hard endeavor, and as time went by, it got lower and lower into dusk, and ended up pretty much losing it in the dusk. I can just show the sequence I have here.
Yeah, because there's enough motion in that ion trail and the dust trail that it's going to blur pretty quickly, right? So, how, you know, that if you could, yeah, is this another animation?
Yeah, so this is an animation of what you were looking at. This is a longer focal length shot.
Awesome.
So, right, Cameron, if you were to get good enough detail, have a fast enough scope and a long enough focal length to really zoom in on the core of this thing, you'd be able to see actually streamers moving within the ion tail. That's kind of what I was going for, but I just barely can't get it here.
That's so cool.
I think it's just, you know, like my telescope isn't that fast. It's shooting at f7.5. And you really need, you know, quicker exposures to get a lot of signal within a single exposure. These, I was taking 30-second exposures on this. And this looks like over the span of a half hour of movement.
Impressive.
But this gives you an idea of what the telescope sees, you know, through the camera at long focal length. These are what the single images look like, and I'm shooting with a monochrome camera, which is why it's black and white.
Well, Jason, you come at a good time with the technology. You're pushing the envelope, and this stuff would have been impossible to do before. So this is really cool. You're pulling it together, and this is really nifty.
Well, this whole topic that Scott and, you know, David set up really got me me in gear to go back and reprocess these, or at least look at these Neowise shots again.
Right.
A lot of the stuff I sat on, especially like the ones where the clouds are moving through, I was like, it didn't really work out. Then I put that time lapse together, and I just put that time lapse together with that video literally 20 minutes ago. It was the first time I saw it. And I'm going to go back to it because I like the way it turned out.
Yeah, I do too.
Well, that's what these shows do, right? I mean, what Scott has done is he created a great forum, and then, like you say, you start to dust off the cobwebs and see what you can.
Yeah. Yeah, so that's all I had for today. I hope you enjoyed it.
You really enjoyed it. It's great.
Yeah.
It's great.
Yeah,
bright Comet outside right now. I go look at it. So.
Yeah, it was one of the things I was considering doing for today, if the weather would have allowed it, which it's not here, but I wanted to, get my scope set up and show how to find a comet, with a telescope if it's not visible to the naked eye. As far as getting the coordinates of it, where to find those, and then where to tell the telescope to point and how to center it on the comet. I think that would be a good demonstration, but couldn't make it work for today.
Yeah, it's as usual. It's cloudy, but yeah, it turns out this is a Tuesday night. It kind of reminds us. I've recently joined a group of really wonderful astrophotographers that Jason's a part of, the Plymouth Astrophotography group, and we all sit around and we share each other's images, and it's a tight-knit community, and we help each other out a lot. And one thing I've always admired about Jason's work, Jason, you do both the wide angle and the deep sky astrophotos and do them pretty well. I've settled on wide angle for the most part, but at times deep sky astrophotos have been something that I've always been interested in. And when it came to the comet, I remember that we were kind of collectively learning. All of us in the group were kind of collectively learning how to shoot the comet and try and present it in a few different ways. And it was a fun adventure for us all. It took our minds off of what was going on with that pandemic and got us outdoors using our equipment. So it brought back memories of a fun time of everyone. And I remember that last deep image of the comet. We had a couple of people who imaged the comet and got that sweeping tail. Yeah. There were a couple of I'll call them celebrity astrophotographers that they're well known for doing their work, and they were kind of the first to come out with some of those larger shots of the comet, and then most of us figured it out, and we watched as that comet nucleus went from the color you've got it there to that bright green from the carbon emission. It's like as it passed by us, the nucleus changed. So it was a fun comet. And yeah, your images, the same thing we say during the Plymouth Astrophotography Club, the images are spectacular, but it's also evident how much time you put in to go out and get them. And that's to me, it's just as important, getting good data like this and then being able to process it.
Yeah, well, unfortunately, processing it into a single image is pretty impossible when you have this many clouds moving through. But looking at this, and I don't know if it's coming through on the video, but you can actually see the comet moving. If I put my mouse pointer over the head of the comet, can actually see it moving.
Yeah.
Oh, yeah.
The stars are stationary. If I put my mouse over a star, the stars don't move because they're all registered together. So
yeah.
So you can actually see the comet then moving away from the head of my pointer.
Yeah.
One of the strangest comets I've seen was called Iris Araki Alcott. and it made, I guess our view of it was kind of like coming head on towards us, because it just had like this, it was like the cloud was like the size of maybe like the full moon. It was huge. And just in an hour, you could see that it had moved significantly across the sky. It's just really a beautiful comet. Very strange though.
Did that one show up right before Hale Bopp, Scott? Because
yeah,
I remember seeing
80s,
something.
Maybe late 80s.
Yeah, I remember seeing it and seeing something in the sky and thinking, "Ooh, that's the comet." But I've always wondered if I was just seeing a blocked full moon or not. And
yeah, Iris was designation was Comet 1983 H1. In 1983, made its closest known approach to Earth of any comet in 200 years. So it got really, really close. It was about, this is 0.0312 astronomical units.
Okay, I may have been thinking of a different comet that I wasn't sure if I saw. Comet Hyakutake, I think, came in, or Hyakutake, if that's how it's pronounced.
Hyakutake. Oh yeah, that was.
Yeah, that's the one that came prior to Hale Bopp, I think.
Yeah, where
like
you just had the huge tail and.
Yeah, like 96 or something. You had Hyakutake, and then out came Hale Bopp with the huge tail, and it was visible in the sky, and then out came the movies Armageddon and Deep Impact. And
those two comets, Hale Bopp and Hyakutake, I mean, it was just amazing to have two incredibly bright comets, like that, just right next to each other. It was, I remember seeing Hale Bopp and seeing, I've seen illustrations where, the technical artist or whatever made like what looked like shells inside of a comet head. And I thought that was artistic license, but it's not so. I mean, Hale Bopp exhibited that feature really well, especially when you observed it through a telescope. And the reason why is because it had jets coming off and the comet was spinning. So as the comet spun, these jets of material are coming out, but then the solar wind would push it back and it would create these shockwave type layers within the comet. It was just beautiful to look at. Hyakutake, probably, I mean, it's very special to me because I took my two young daughters out and they still remember it to this day with the tail stretching halfway across the sky. It was beautiful. Yeah. I made him get up in the middle of the night and I said, get up, we got to see this, so.
Yeah, it's going to only to be outshined by Hale Bopp a few months later. It would have been the comet up until Neowise here. But then Hale Bopp, for those that saw it, just how bright it was. Neowise did remind me of seeing Hale Bopp, but I remember somehow that Hale Bopp just seemed a lot bigger in size. But this was a wonderful reminder of it.
Yeah. I saw Hale Bopp from the city of Taipei, Taiwan, which was incredibly light polluted, but you could see it.
You can still see it.
Yeah. And I'm trying to remember another comet. Maybe it was Comet Austin, but I remember seeing the bright head of the comet, just after sunset, and so it's still daylight outside.
That's a very impressive picture, Borisov. That's
look at that.
Yeah, there's the Hale Bopp. There's Hale Bopp right there. I think that's what he was looking for. Yeah, and it just hung in the sky like that. But like you're saying, there have been some bright comets. You were talking about the one you just saw. I think you saw another one in Taipei.
Hale Bopp. I saw Hale Bopp.
Okay, the Hale Bopp was the one you saw in Taipei. Okay. Mm-hmm. Yeah.
Of course, I saw it from California too, and so it was amazing.
It wasn't hard to miss.
No, I mean, it's
it was there for so long too. It was great. You know,
not even dark in that picture.
Yeah. Yeah, that it reminded me of how when the comet finally became a night comet, you could spot it as twilight was leaving, and then if you had a low horizon, you had maybe an hour to image it as it began to drift to the horizon, to the north. I thought that that Neowise was visible in the southern hemisphere, Cesar and Maxi, but it didn't get spectacular till it crossed over the equator and showed up in the northern skies, where it was close enough for all these images.
Yes, normally lost a lot of bright, but
in the north of the country, he was able to see it.
yes, many people take pictures in the area of Jujuy because Argentina have the northest latitude at I think that is 23,
passing by the
23,
the Tropic of Capricornio.
Oh, Capricornio, yes. Yeah. But from Buenos Aires, Buenos Aires is 35, very low. The bright was particularly fine, not like the worst part is when we are watching, and especially now with the social nets, is that we starting to watch the pictures from the north hemisphere, and we start to wait and praying to have something come on. Don't use everything, the comet. Yes, don't take all pictures because yes, it's
we
like
took that whole comet for ourselves. I mean that's what happened.
Yes, people from Argentina, New Zealand, Chile, and Australia, every time we suffer, they say, come on, let us something for us.
Yeah, and then we go back to you and say, you have the Southern Cross and Ada Carina. So we throw it back into your faces. You've got the Centaurus A and Omega Centauri, even though that rises high enough to see in some parts of the northern hemisphere.
Yeah, tonight I have some pictures of one star party in particular of 2013 that I remember that we take some pictures, single picture of 30 seconds of the Milky Way. Unfortunately, I don't have more than experience because I have pictures. I have very bad pictures for comets, but I had more strong experience at the naked eyes about comets. But I was amazed with the pictures of Jason because and the time lapse really I enjoyed this presentation, Jason.
Yeah, me too.
Yeah, please. You want to take the screen share?
Yeah, I think that it's okay. You can use all Comet because you enjoy. If the comet coming to South Hemisphere and bright less, no problem because you enjoy and use the comet live in a great way.
Yes.
Yeah, this is something
thank you, man. Thank you.
Yeah. Yes. It's great. Very inspiring, Jason.
Yeah. Beautiful stuff. I think we could just have a show of nothing but just image after image after image of comets, maybe we'll do that sometime.
I'm tapped out now.
Very cool. Very cool. Well, let's see. Up next is Conal Richards. Conal, as I recall, you're 16 years old. Is that right?
I'm 18.
18. Sorry. Okay. Sorry. Well, that's a big difference between 16. So.
No, cool. 18. Oh, it's old.
When you're 16, you think the guys that are 18 are really pretty old. Okay. So.
No.
And when you're 18, 16-year-olds, like a kid, right? So Yeah, that's right.
Yep. And
Yeah. It's
his
just when you're old guys like us, that it seems different.
Yeah.
but never too old to forget. The favorites when you're in college, you always have a favorite thing. And for you, you're learning the words "We are Penn State."
Oh yes.
Yeah, Big Ten. The Big Ten goes deep. I'm still not sure I forgive you guys for coming into the league and kicking both our butts, ours in Ohio State. I graduated from Michigan in '97. The first year Penn State joined, a little bit of sports trivia. Penn State joined the league, and then in '96, around the time of Hale Bop, Penn State was a powerhouse in the Big Ten football scene. Beat everybody. Said we're in the Big Ten now. Then things changed a little bit, but we won't go into that. But yeah, that an iconic football team, and thanks to Conal, obviously an iconic school with an iconic astronomy program. So that's my little personal Big Ten introduction to Conal.
Good one.
Thank you. They do say, well, historically, comets have been said to be harbingers of great things, both good and bad. But I'm going to move us out into interstellar space, actually. Can everyone see the presentation all right?
Yes.
Yes, looks good.
I'll load that up here. So we were talking earlier, many of us tonight have mentioned Comet Hyakutake as a favorite observationally and a favorite comet that we photographed and shared with many others. But there are some interesting mysteries surrounding that comet. So here's a beautiful image of it here. This was from one of NASA's APODs, and it's got that bright green head and then the streaming tail behind it. It looks like there's a bit of an ion tail going straight back. It's kind of hard to, pull them apart, and then the dust tail pulling away slightly. But again, it's a beautiful comet.
Look at the piece that's up at the top left. It looks like it's swooping in, and I'm just wondering if it's a piece of the comet that broke off or a section of the tail that's different somehow. I mean, it looks different than a dust tail.
I do wonder that.
It looks like ion tail.
Yeah.
In the upper left.
So, like I said, it is a bit of a mysterious comet. And we start to kind of look at this thing by looking at the orbit here. So we can see the Earth is moving along in this graphic here. This was back from when the comet was flying along. So it's moving to the right here from our perspective. But then the comet is moving around this way. In fact, Comet Hyakutake was in a retrograde orbit. And you can also see it's highly inclined above the plane of the solar system. So we have the plane of the solar system stretching out, and all of the planets are there, only differing by a couple of degrees from that point. And then they're also orbiting all in the same direction, but not Hyakutake. It's coming around this way, the opposite direction, and at this very inclined orbit. Now, we do understand from many other comets that if you go beyond the Kuiper belt and into the Oort cloud, it becomes less of a disk and more of a sphere of this original material from the solar system's formation, all this ice and gas and dust. So it's not uncommon when you're so far away from the sun and the gravity is much weaker for collisions to bump comets and put them in these really strange orbits to have them come around. Now, last I read, Comet Hyakutake's current period is about 70,000 years, 10 times what we know for Neowise. But anyway, like I said, it's coming out of this Oort cloud with this really strange orbit, and it made this spectacular display in our night sky. But that wasn't the only thing it taught us. So around that time in 1996, when it was coming around, there were some astronomers from JPL who took a look at the chemistry of it. And they found that ethane was a compound commonly found in many comets, but not in Hyakutake. It was depleted, or it was gone, or it was never there. And this led them to conclude that the comet may have been, in fact, an interstellar comet, almost similar to Oumuamua or Borisov. Now, they recognized that many comets that we see in the night sky, or many comets passing around from the Kuiper belt, did have ethane and methane. But the reason they said that Hyakutake did not have these is that it formed much farther out, potentially in interstellar space, where there was some greater concentration of material, or from another solar system where it could come by and become captured. Now, the evidence for this comet being interstellar is not as strong as something like Borisov or Oumuamua, where we saw it coming in on a hyperbolic trajectory, way faster than any collision could have bumped it towards the inner solar system. But it is really compelling to think that there could be comets in our solar system right now that have come from other stars and that have actually come to stay. So our next interesting target is the famous Oumuamua, the great interstellar comet that came by, and it was the first we'd ever seen. Now, as this was happening in 2017 and 18, we commonly saw this cigar shape type of artist concept. We were trying to look at the brightness of the object and how it changed over time and how it rotated. And it was sort of this pencil or cigar shape that we came up with as a likely form for the comet. Now, also while observing this comet, we noticed it was accelerating out of the solar system like some comets do with gases emitting and jets and things like that, but we didn't pick up anything spectroscopically. Now, a couple years went by, and we come to the modern day now, just 3 years later, and we've made a number of interesting observations about this in addition to what we saw in the first place. So now we suspect that Comet Oumuamua may have been not a comet at all, actually, something more like this pancake-shaped chunk of nitrogen ice from what we could call an exo-Pluto. Now, I have an image of Pluto on the next slide that we could go into a little bit more, but the suggestion that this was more of a pancake shape rather than a cigar shape came from looking at the object. We realized it could have been spinning edge on, like we see some galaxies or some objects in the night sky, and that it could have actually had this format. And that would have led us to conclude that it was made of nitrogen ice, much like some of these oceans on Pluto. So if we remember from 2015, when New Horizons came and made its flyby, we found these vast, and I call them oceans, even though they are frozen, these vast sort of chunks of liquid nitrogen that had frozen on Pluto's surface into the shapes like the famous heart or Sputnik Planum down here. And it is very possible that an object like Pluto could have existed around another star, and that some impact, we know these are common in the Kuiper Belt, came and struck this dwarf planet similar to Pluto and blasted off this chunk of nitrogen ice. Now, of course, it would have gotten much different in its composition as you would go deeper into the planet's crust. So you would have a thin sheet that's very wide and very long, something like a pancake shape that could have represented what we saw with Oumuamua. Now, a lot of these observations, we were trying to look at this comet from another solar system. We were wondering, do comets change as they pass through interstellar space? Are other solar systems different, and are we somehow unique? But it turns out with the passage of Borisov, we saw some beautiful images earlier of that comet coming by. That comet looked a lot like the ones we see from our solar system. So we can make some really interesting conclusions coming from Borisov, Oumuamua, and Hyakutake, as I spoke about earlier. So first with Borisov, we can see that that comet was a lot like some of the ones that we find in our own solar system. So we can conclude that comets are common in the outer regions of other solar systems. And I say the outer region specifically because they are cold, they haven't broken up, they are still in that icy, loose gravel kind of form that we've observed with many comets. In fact, that's why they break up so easily, like for something like Shoemaker-Levy 9. And we can also conclude, based on the first interstellar asteroid that we found, is that these exoplutos, these dwarf planets orbiting other stars with these large seas of nitrogen ice, also exist. And what that teaches us is that other solar systems, as we've found, have planets, and that they may also have dwarf planets similar to our own. So as we're trying to pick apart these pieces of the interstellar puzzle and figure out what other solar systems are like, we're comparing and contrasting how ours is unique and different. So this is one commonality, which is really interesting to find, is that you might call them the Kuiper belts of other stars actually have their own dwarf planets and their own comets and maybe even their own Oort clouds. So perhaps we're not so unique as we may have thought before. Now, also what Hyakutake teaches us is that comets do fly between interstellar space, And if we found 3 of them, as long as we've been searching, which you might call a couple decades or a couple of hundreds of years, if you count the visual comets that other observers picked up, that's a very short time on the astronomical span of things. So if 3 comets have come in the time we've been searching the night sky, then perhaps it's much more common than we think, and that comets do pass between stars, and maybe some of them even come and stay like Hyakutake does in this highly inclined retrograde orbit, where it's moving very fast close to the sun and very slow out towards its apogee from the sun. So again, these comets give us a great sense of perspective. And I'd like to close with some images of my own of Neowise, which is a much more typical comet. Nothing special, nothing interstellar, but beautiful nonetheless. Now, something interesting I learned about this is that the tail was about 6 degrees. I saw that in my own observations and heard that from many others. I was using binoculars with a 5-degree field of view. So that took me from maybe the nucleus at the bottom and some way up the tail. Perhaps the pictures don't reveal all of it, but that corresponds to a tail of about 7.5 million miles long, which is absolutely huge. So it's really strange to think of these comets being huge structures taking up significant portions of the solar system. David Levy said Hyakutake's dust particles spread from the lowest point in its orbit near the sun and the Earth all the way out to Jupiter. But as huge as these structures are, they are also very tenuous and thin. Only the evaporated bits that come off of jets and come off of the ice as the comet sublimates. And as much as we like to observe these, as much as we like to appreciate their beauty, they do move out towards the outer edges of the solar system, and long period comets like Neowise that come around every 7,000 years, they do get smaller. So this next image here I took from a state park nearby in Pennsylvania. It's a beautiful one up in the Northeast.
Nice.
So we had a campfire glow down here, and there's Neowise again, looking much smaller compared to the earlier image. These are on about the same scale, and it's kind of receding into the summer sky there. The first image you saw was taken on July 15th in the morning, and this is when it swung around into the evening skies, Ursa Major, and I can't pick out the stars too well from here, is kind of dangling up here. I remember finding it just under the handle of the dipper, or the tail of the bear if you prefer. So the interstellar comets, they are really fun to learn about, but just like the comets in our own solar system, they come and go quite quickly. So we might as well stay and appreciate what we can learn from them and what we can see.
Wonderful. I almost feel like I'm out camping right there. You know, I can hear the nocturnal sounds in that photograph. It's beautiful.
And they do say one of the great things about astrophotos is that you know, anybody can look up a picture of what the comet looks like, but you know, I remember the story with when I was taking the image. There's a campfire down here. That's actually my cousin there in the bottom right. I said, you know, wave your arms or make a pose or something, and we had some fun with it. But
Sure.
But that was a really fun night, and it's fun to capture those images and share them with people, along with the story that comes with them.
Yeah, that's right. That's right. Excellent job, Conal.
Thank you very much, Scott.
Thank you. Okay. All right. Up next is Adrian Bradley. Adrian, do you have more to share with us tonight?
I do. I was gonna say, for Conal, you have to end all of your presentations with "We are Penn State."
Oh, everything's a Penn State advertisement now?
Yeah, it'll come that way eventually.
Give it like 6 months once I'm there.
Yeah, you might, but no, excellent presentation, beautiful pictures. So in line with Jason Guenzel's pictures and your pictures, my presentation is basically going to be just to share a few of the images that I always go back to this images that you can take with a camera. You can take pictures of blackbirds in flight and freeze them, or you can find your Comet Neowise photos and just kind of go through the history of the title of the presentation was Milky Way Reflections. So there will be some Milky Way shots in the middle of these. The morning I decided to get up and go see Comet Neowise here. I do believe this was Venus, and then the Pleiades rising. And I'm not a morning riser. The moon was out, but then as morning began to rise, I began to take some pictures, and there was this streak in the sky right here as dawn was beginning. This is Auriga over here, and there's that streak. And I looked at it with my binoculars that I had, and I took a few photos, figured out some settings, and then what you've got here, my first
There you go.
view of Neowise from
Excellent.
the dark sky park. So these things, it evolved as it came
So
out.
beautiful
This is
picture.
one of the
That's
yep,
nice.
this is one of the clear pictures. Yep. That was before Neowise rounded the sun, and I tried to take some close-ups.
Whoa.
There was a pinkish glow from the sun rising. This is it should focus here anytime soon. If it doesn't, we'll just move on. But yeah, let's look at that one too. Yeah, just trying to experiment and get some close-ups. So that was on the 9th. And then in the light polluted skies of my backyard area, I took a big camera, 150 to 600 millimeter camera, and pulled Neowise out. And these images will probably not do it too much justice. But yeah, there we go. Trying to capture it in a light polluted zone, and this was what I got. So those were images, and then 4 days later, I see Neowise, and this was my first shot. I'm leaving it the way that I saw it, unfocused. I was going, oh man, I thought I had it in focus, but I gotta do a better job of that. So I took a few more shots, and then I'm like, oh man, everything's moving. I got star trails. The comet, it looks like a pancake with a tail on it. I gotta fix that too. And so I worked at it and finally began to get some roundness in the stars. This is essentially what my naked eye view was of the comet. It's what it looked like. And at this time, you're starting to see an ion tail already. So I processed a couple of them, try to make them look really cool. And this is the comet shrinking and falling. This image turns out to be.
There you go. That's nice.
Turns out to be decent. And then I experimented with some fishermen that were there, didn't know. So I took a long exposure and had them stand as still as they could, and then shine a flashlight so that they would be illuminated near the end of the exposure with the comet coming towards her head. I may try and reprocess this to smooth it out and sharpen them out. It's an interesting thing. When you're shooting night sky images, you rarely get round stars and reasonably sharp people because they're forced to stand there for 20 seconds. They were nice enough to do that. I was pretty happy about that.
Yeah.
I kept shooting until it got really low to the horizon, and so these are your pictures. You saw Jason shoot a picture similar to this where it was low to the horizon at Kensington Park. That's probably as clean a picture as I could make. And this was at Lake Hudson Dark Sky Park. Now I'm looking to see, don't worry, the Milky Way was, I turned around to the south and there was this really clear night sky with the Milky Way, a meteor that came through this particular image. Bortle 4 is the Bortle rating of Lake Hudson Dark Sky Park. I used a tracker to image this and ended up with a pretty reasonable shot here. There's Jupiter, there's Saturn. And I see the note that my internet connection is unstable, so you may or may not be seeing these images. But so yeah, here's what the Milky Way was like after Neowise sank, and I said, okay, I'll take some shots of it. And I even got some rising moon pictures too. This is the moon when the moon is rising late. You've got the your past third quarter, and you've got this crescent right here. So I named this called Check Your Rig because I took a bunch of fuzzy shots. On the night of the 18th, I missed a golden opportunity. And I think I'll just show this kind of fuzzy shot. But I missed a golden opportunity as I was setting up a meteor, a bright green meteor shot this way, right above where the comet was in the plane. You imagine having a dual shot with a meteor and a comet in the same frame. I missed the opportunity to have that. I might have submitted it for APOD. I would have tried. I don't know if I'd have gotten much, but I did get this cool shot right here when I finally got things in focus, or mostly focus. It was very cloudy and hazy, but the light of the comet with the ever growing green nucleus was still visible.
It's pretty.
Adrian, it's amazing, this picture.
Yeah.
Yes.
I like it.
And yes, I almost didn't show it just now. I was going to skip this part because it was all clouds and fuzzy, but I did remember getting a pretty good shot out of it.
Even the color of the stars. Look at that.
Yeah, it's beautiful.
Yeah.
You got the ion tail there too, you can see.
Yep, there it is. So it was, a lot of those features are visible. This was a 200 millimeter camera that I used with my Canon 60 and my tracker. These two stars are important for the next picture. And this is when you don't have your tracking working, and this is what a raw frame looked like. So it took a little bit of processing and I got a cleaner shot, did some processing, and all this data came out. Again, if there had been a meteor shooting through here too, I would have been beyond happy, but I'll take what I got. So Broward Nature Preserve, I went there the next night to do some imaging. The owl cluster, I tried. I said, deep sky shooting isn't mine. You're seeing something that I'm going to put into a time lapse. And then there came the comet, and I took some images of it. Let's see, there are those two stars that I pointed out. The comet had moved to be over those two stars. I think they're part of Ursa Major. The comet is below the Dipper. I took a few shots, tried to stack them, but I ended up processing one image and I ended up with this shot. This was probably the best of the shots that I could took. You can actually see that sweeping remnants of this sweeping dust tail here. You see the ion tail,
the two tails
pulling directly, and I was able to, darken the back of the night sky. I think this was a 2-minute. This was a 2-minute exposure, and there go those two stars. I used to know the names of them. But this is a lot of the better comet images came on this night, 7/19. That's when most of the good images came out. And I will go ahead and end my segment with this shot, which, this was a shot from my artistic side. I thought was, you have the comet here. It's just a part of the scene with all the bright stars in it. The Dipper's above, those stars were missing here, but you have all the fireflies. It looks the way that I ended up taking the shot, it probably looks like a painting. And that was kind of the intent. I ended up having this printed out as a canvas. And for those watching, if you would like a copy of this print, it is available.
Beautiful.
But last but not least, the comet sinks. So what do? We turn south and see what kind of Milky Way we can get. This is a Bortle 5 zone. Somewhere between Bortle 5 and Bortle 6, because it's near Ann Arbor, Michigan, which I can tell my internet connection because you guys all freeze, so I know it's me, but you're all back. This is what Bortle 5 skies or Bortle between 5 and 6 skies, the Milky Way imaging you can get outside of Ann Arbor, Michigan, home to one of Conal's rivalries, the Wolverines, where I graduated in '97. We've had hard luck with our football team, unlike Conal and his soon-to-be school. You can see the Scorpion here, and you can see Sagittarius here. Jupiter is now way over here, and Saturn has moved to about here next to the Milky Way. So it is a little bit different now, but comet chasing was a lot of fun, and it always is, but there's never anything quite like Milky Way chasing, which you can do all the time. And I will end my final image with a recent shot, because chasing the Milky Way is what I like to do. I think I showed pictures of it in smoke, but somewhere in here is the latest image that I've taken. Now, if I had come to the thumb and done comet imaging out here in the thumb, I might have had the comet against a backdrop. And let's see where did that go? Yeah, my comet might have been against a backdrop like this. You've got Andromeda.
Mm-hmm.
I might have shot north, had the Milky Way, the Cassiopeia image of the Cassiopeia region of the Milky Way over here, and the comet over there. When it's darker, this is more around Bortle 3. When it's darker, you can do that. But when you are, let's see, this was 724. But when you're at a site that it's hard to, and this wasn't the I think this is it right here where I did sunset, and I tried hard to get, and this is going to be the final shot, similar to Conal's. The winter Milky Way is over here somewhere, if this ever loads. Yeah, the winter Milky Way is over here. It's hard to see because the way I imaged this, I didn't do a good job of pulling out any of the Milky Way detail, but there's a comet. And these are the stars of the Big Dipper right here.
Right.
These stars are kind of buried in with all the stars. And there's the comet. I highlighted the tail a little bit, exposed the tail a little more to make it a little more visible. That's the comet sinking below the horizon. This was the last shot that I took. There's a little bit of nebulosity here. You can see it. That's from the winter Milky Way, the Cassiopeia region. I'm not sure if Andromeda is visible. In fact, I don't see it here. This was one of the last shots that I took. My farewell to the comet. This is looks like I tried to process it a bit, and get some data out.
Oh, there you can see the fan shape of the comet in this shot.
People were out there. Yeah, you can see it. You can see the van. There were folks imaging that night too. There's a Dipper. Little Dipper just disappears in the all of the stars that are out there. So as always, I always tell everybody, even if you don't have, all of this stuff was done with a camera, and anywhere between a wide angle 14 millimeter lens, and a 200 millimeter lens. All f2.8 fast lenses are always good for getting a good deep sky images. And if you can use a stock camera and get good images. If you turn around and shoot at the Milky Way, a stock camera will still give you good images. If you turn around and use a camera that, if nothing else, shoot the sunset. And if you have a modified camera, you get even more detail of the Milky Way from those same sites. You start to get more interesting things that are in the Milky Way if you use a modified camera. So that's it for my presentation. It was fun shooting at the Comet, whether I got a good shot or a fuzzy shot. It's just always nice to see what you are, see where you are, then take the image. If you don't get a good image, you at least have a good memory. So with that, that's the end of my presentation.
All right. Okay. Excellent. Okay. Adrian, thank you very much. You know, I feel like I'm just immersed here with you know, comets and thoughts of where they come from and you know, just especially the interstellar comets. It's just to think about them maybe going around one sun and then hanging out and going around another sun and being flung out again. So it's just it's amazing. Our next speaker is Maxi Filares from Argentina. Maxi,
Hey
thanks
guys.
for hanging in there with us. Beautiful image of the Leo triplet back there.
Yes, this
I
was
love that.
from La Pampa this year when
Yeah,
I been
65,
stuck in that
66, and 3628. Beautiful.
Thank you. So, well, I'm a little tired because today I have my first vaccine, and so I think it's
Oh
going
yeah.
to get
Wow.
effects.
You are a brave guy to stay with us all this time. Okay.
So I try to be in the after party. So
yeah.
Okay, basically what I want to show you is a little short of my pictures of my comets that I took from when I started in 2018. Today when I was talking with you and David, I was talking about when I went to Mercedes. So let me show you my screen. So
Okay.
okay, you see?
Yes.
Okay. So basically, like I say, in December 2nd, sorry, of 2018, this was my first shot of the Comet 46P Wirtanen. This is from my house. I was taking my 30 seconds without a motorized mount, only the tripod. And then the next day, obviously has light pollution here because it's in the city. This is the same triangle of stars, but the comet passed here from here. Then the other day, I went to outside of the town. You can see the triangle, and here's the comet. And then in the another day, I went again, and it's here. So basically, you can see the movement in only 4 days.
Right.
Then in the 14 of December, I went to Mercedes, and this is a little stack picture put in my cell phone above the 25 eyepiece and the max photo, and a little bit process. I didn't know how to process these images, but this is the Wirtanen comet. it's a brighty core, and if you can see the coma, but it doesn't have a tail. So unfortunately, we never see the tail of this comet. Then, well, this is that night, the group of amateur astronomers that we went. This is me, my brother. This is our two friends from here, from Chilcoy, Jose Luis, Alan Gedin, his fiancée, Mario Gorelli, Sebastian, and this is a friend from him. You know these guys, Cesar, now? Some kind. You're mute. You're mute.
Yes. One. Let me see. 1, 2. Well, you 3. Yeah. Yes.
A few.
I think that. Yes, I think that the most of them, I know them. Yeah. Yes.
Okay. Okay. Well, this is from the last year. I start to put in my backyard the telescope. This is the F5 150. This is my Sherman Shepherd, Luna Moon.
Luna Moon. Good name.
She's always, when I put my telescope, besides of the mount every time, but she's still there. So she's don't have any problem. So this is my first time. I tried to take pictures with the DSLR camera from the Comet C2020 F8 Swan, the Friday 17th of April, but it doesn't have a lot of information. It has a little tiny tail and the coma, and the core was bright, but I didn't like it. So this is, I remember I thought, oh, this is what I took. Oh, this is very okay. Let's post it and wait from another days. So I spent from 2 of May, the 2nd of May, only 15 days. So the pictures and the comet changed a lot. Here's the core, the coma, and start to be the tail and everything. So that's why I really like it. And this comet has a huge promise from here because it maybe it was have to be like Neowise, but unfortunately, a few days later, it tears apart and dissolves. And that's it. We have no more Comet. So then this is a little animation of all the pictures that I take. The orange is for the light pollution, and also you can see a tree passing by from my neighbor that he never cuts it. And well, that's why that's a lot of movement, but you can see how it's still moving from here.
Right.
And I think this was only in 1 hour, maybe. So basically, I have a lot of information to work, but unfortunately, that tree doesn't want to take it.
Yeah.
Yes, don't cut the tree.
No, it's from my neighbor that he's never in there, but the tree is very huge, in only pointing to the east. So everything I have to the east is the tree. That's it. So, well, in a few days, I think it was at the end of May, the common lemon, the C 2019 U6, appears to be growing to be shiny. And well, I pointed to this, so the swan goes by. We have lemon. Let's go to lemon. And I was start to practice in processing, stacking, and you can see here it was only to get start trails because I was stacking only the comet, and there wasn't a tail or anything. But a few days later, I tried again. So I have the core, the coma, and a tiny tail, basically. Was in May 28th. Here's my equipment that time. So I'm try it. Maybe the huge promise it was at the end of the year. Maybe I hope so. So let's see what we can take. And this is from the Comet C 2020 Atlas M3. This was the last comet that I took pictures. This is reminds me like Wirtanen because it doesn't have a tail, only coma and the core, and obviously a huge bright green light. So I remember when I pointed with the telescope and I put my eye to the visor of the camera because I don't have a live view to get focus. And when I see the very bright in cloud of that in the image, and that was amazing. I remember that. So basically that was my little experience with comets to try to get these pictures of pointed stars and pointing comet. It's a huge process. Trying to because when you stack you have to stack only the star from one side and stack the comet on the other side and then grab it together. But when you put it together, you have the pointed stars and the comet, but you also you have the star trails, and you have to try to move it away. So basically, get pointed stars with the pointed comet. It's very difficult, but with practice, and Adrian, I see you're going to try it in fixing site. Prepare it.
Yeah, maybe I'll put it off for another month. But I assume there are routines in PixInsight that help you do that sort of thing.
Yes, maybe there are many tutorials in YouTube that maybe it can help you.
But it's so easy. Yeah. Come on. It's only for your generation, Maxi.
No.
Come on.
Well,
yes,
that's why I take a 2-minute exposure and hope that I can get enough good data to have a good picture in 2 minutes as opposed to separate stacking, because it just gets more complicated. But it's the way to do those faint comets. If they're big, you 2-minute exposure and you have it. But but these faint comets, you have to do that almost.
No, the work that you Maxi make with PixInsight, come on, you're crazy. But no, yes, it's the same. Normally, when I start to make my son Agustin is here, and when he watch me starting to process with Cyril or another thing, say, come on, stop to make this. Give me the lights, the darks, the everything, and let me make something serious. No, yes, he left me stuck. He's confident with my stacking process, but normally say it's not okay. I prefer use the PixInsight. Normally I use more Cyril or something more easy, because maybe I am really old school, but I'm really think that it's a great software and make really an excellent show with your lights. But it's like you tell that if you have a lot of information, maybe 200 pictures, I think that for when we have small information, or like sometimes we have small information from the city, sometimes I say, okay, I try with free softwares like Serial or another ones. I know that maybe Deep Sky Stacker is too basic, maybe, but
no, it works out. Works.
Yeah, I know it's just it's basically a learning curve.
Yeah,
to pick it up, and the curve is like this, and the free falls are like this. But then once you pick it up, like we have an astrophotographer in that group I talked about, who has a 15-minute process. He goes for accuracy in the images. He doesn't worry about them being the prettiest, but he's learned PixInsight enough to take his data he's got good data from his observatory.
Sure, yes.
And he runs it through a 15-minute process. He does things to it. He also uses topaz denoise, which I like using as well. It's really good.
Yes.
And it's gotten better. And within 15 minutes, he has an image that he's fine with. It's accurate, it's reasonable focus, and it's got data. And he's like, yeah, I'm good with that. We also have, like, Jason, you saw how he's able to get his images, get real deep images, and
yes.
we all have a style of how we do it, and sometimes we just want to get good data and throw it through a filter or something, present. Other times we have the time to go through step by step. So it's it all becomes preference after a while.
And
so
today you give us a great surprise with the Comet pictures, because we never suspect so great Comet pictures with landscape, and really for me was a surprise, because yes, a beautiful landscape with the comets. Really we was, wow, come on, this guy. Northern Lights, Milky Ways, and now comets, beautiful comets.
Sometimes the focus was on the comet itself. When I was at the nature preserve, where you had the tree and you had the comets, just this sort of little thing off in the distance. Sometimes you're taking a point in time, and you have the whole scene to look at. I wish I had been going to the thumb, because the comet would be on top of the lighthouse or near the lighthouse. There'd be something going on there. And the Milky Way is brighter, so there would have been this combination. But that's for the next one.
You three guys, Cameron, Maxi, and Adrian, you don't need to be encouraged, because you make something with it. Okay, I use my cell phone to make this galaxy. Cameron say, okay. I say, what do you see? A reflex camera? No, my cell phone. Maxi, you with any landscape you make. Only you. Maybe the next thing was your picture, Adrian, with a comet, a lightning ball, with a storm, Northern Lights, all in the same picture, because
well, that's what you hope for, two or more things to happen at the same time. Yeah,
the fireflies with the comet. Come on, how do you say all
a
together?
Reflection in the lake with the comet.
Come on. I see that.
There's actually one of the shots I took actually has a reflection of Jupiter in the lake. It was that bright, and I don't think I shared it with this one, but future star party, I'll have to share some of those, and I got to go out and get more images.
Come on, guys. Come on, guys.
So Cesar,
this is the expression for you three.
Yeah.
I don't know if Cameron is. Yeah, Cameron. Come on.
Cameron to see.
You
Look
too,
at sneak
man.
back into the picture. It's always cool watching Cameron just sort of slide back into the picture. That's nice.
Yeah.
Come on.
Come on.
Come
on. That is our word for the night. Comets. Come on. Speaking of come on, I'm gonna have to.
I can just imagine what the night will be like when we get down to Argentina and we have some pizza and a couple of drinks.
Yes, of course.
Right on.
That's gonna be. I look forward to that. I gotta get down there.
It's coming to be real. Yes,
yeah,
absolutely.
You'll see me imaging with the cell phone on a tracker.
You gotta be there. So
yeah. Well, I'm gonna be there. It's 1:00 Eastern time. To those that are hanging on, we thank you all for hanging on. But I am going to drop so that I can be sort of awake for work tomorrow. So Cesar and Cameron, I will probably be watching your presentations from the recording.
Yes, tomorrow.
Be looking forward to seeing those. And thank you all for watching. And David Levy leaves early, but just as a reminder, it's Comet night.
He's probably out looking at comets right now.
Yeah, he's out looking at comets right now, probably, or looking forward.
There are, I was something I want to show just before we go over to Caesar here. I wanted to show this page. This is a comet page I've been looking at for a long time. Saiichi Yoshida, I believe, is the guy that puts this together. Now, he calls these weekly information about bright comets, okay? So we start off with Comet 2020 T2 Palomar. It's in the 10th magnitude range.
That's Carlos Labordena from Spain. Carles from Barcelona.
Yes, Carlos, yeah.
And but look at this. I'm just going to scroll through this really quick. There's like almost 70 comets that people are keeping track of right now.
No, yes.
It's
another
crazy.
Neowise comet. It's A7 though. It's not the one that
excellent tracking.
Excellent tracking.
Yeah.
Yes.
Yeah. Some of them getting down to 16th magnitude. Now, certainly in the early days, that was pretty much out of reach by amateur astronomers. But with, cameras today, cooled cameras, you can definitely get down into these ranges and start to image and submit data to a site like this. So, I mean, it's quite a bit.
Yeah, the old Neowise comet we took all the pictures of that looks like it. I guess it's 24 magnitude. Molly told us that, so it's not on this list anymore. They do have another Neowise comet.
There's one right there.
Yeah, discovered recently.
21A7.
Yeah, it is not observable in the northern hemisphere.
Right,
and it will be unobservable soon in the southern hemisphere.
There's a lot of comets that are like that. So
yeah, it's just not observable.
Not observable in the northern hemisphere.
But when the comet is incredible, is seen to naked, is visible to naked eye, is in the northern hemisphere.
Well, we'll be sure to get pictures of it for you. All righty, it's always a joy to be a part of these global star parties, even if
thank you very much, Adrian.
I'm staying up late to do it. We'll talk with you all next week.
Okay.
Okay.
See you then.
All right.
Yep. Next week we'll our next global star party will have Caitlin Ahrens from Goddard Space Flight Center. She will be the host of the show, and of course, it's a lot of this is going to have to do with the anniversary of the Apollo moon landing on July 20th. So
Yeah.
So I'm excited. Yeah, but Caesar, it's all yours. Here we are.
Well, okay, very
Let's
very
go,
fast.
champion of
Very fast
America.
because I'm more interested in to see the pictures and galaxies of Cameron tonight, or comets especially.
Yes.
But I don't have comets. I'll share my screen to show something very very common. Like I choose an star party from many. I
Oh, look
choose
at that
the
graph.
2013 star party. All are in Mendoza, in San Rafael. For me, it was an idea to watch one star party, choose this. Yes, the typical things where we start to preparing the things, in this star party, we choose going to San Rafael, Mendoza by plane, take a flight, and send the things by. We normally use or the same plane, or to send the telescope and all the material, or is safer because they keep much better the things to deliver by bus. And we take the plane and we deliver all cases and telescope by bus. We take a plane in Buenos Aires airport. This is a local airport only for domestic flights. And this is one of the places near to the star party, one of the lakes that is in the area. You know that the biome is very, very dry. It's have a really clear skies. This is another part of the lake with the dam. This is the hotel. Actually, we are renting a hotel without these walls, with more clear horizon, but it's a wonderful. The sky is the same because only we move 5 kilometers from this the last hotel that we use. Well, this is the head of Scorpio. This is Antares. All are single pictures with no more than 30 seconds, with maybe 1,600 ISO. It's ISO, sorry. And Milky Way in the place. Yes, all are single pictures.
Beautiful.
Yes, the Southern Cross is over. The Southern Cross is over your head here, because you can see the trees. And here is a picture. This is the first night before the star party, when the people coming and are going to the hotel and preparing. And we normally play with pictures with like this, touching the Milky Way. It's a little of fun. This is the Magellanic LMC, big Magellanic cloud over the trees. Here you can see again the Magellanic cloud, and this is the first night of the star party, fully of telescopes. Maxi, you never came to. I think that the next year we are awaiting you for everyone. A Light Bridge telescope, 14 inches. 16 inches. This is M7 in Scorpio. another view of the third party.
Well, you really got the you got the setup and the settings just right, so you can do this anytime. It looked like, I mean, really nice system, very reliable, good quality, nice dark sky, and then a really good foreground, beautiful.
Yes, it's something that this is this is 8 years ago, and the quality of the pictures is not the same. Today it's more easy to make something better than this, but we had a lot of fun making pictures under the Milky Way,
Come on, it's really good.
Yes.
Yeah, it's very nice.
A single shot of Milky Way in San Rafael, Mendoza, no more than 30 seconds, very bright color of Milky Way. Yes, it's a place where you have maybe 25% of humid. It's really dark. It's like Arizona, United States.
That is nice.
Here with friends, sometimes I remember that the second night we start later, before to start to see the sky and take pictures. We say, okay, we can do it. We can make a picture with flash. Of course, never more after this. And we needed half hour to recover, the eyes from the darkness. And this is really we make like a small scenario with music, and this, of course, this quantity of light is really low. We use only the quantity that the musicians need to see the partiture. I don't know what's the name in English. We call it partitura, but I don't know the name what the musicians read.
The music sheet.
The music sheet? Okay. Okay. Only the quantity of light. Jaime Garcia and me, you can see a younger Cesar, not today. We are in the end of the star party, talking with the people and making deliver prizes for the people, contest, or maybe with numbers, with the people that are lucky, the telescope, the prize, and a lot of people in our third parties talking with the people, the final talking, and every third party is an amazing experience, really. Every year we make 2 or 3, and we enjoy it.
When is the next star party, Cesar?
Our next third party is we are trying to start in April 2022.
Okay.
Yes. We have reserved for us the hotel, and we are awaiting that we have all resolved about vaccines, or actually. We have a low quantity of people with 2 vaccines and doses, and of course we think that it's okay for April next year. No, this year we think that this year, and we had opportunity to get the hotel for October. But we think that we prefer make another one virtual, or starting in a safe way next year in April. That is, and this is Venus from the same year in another third party. Venus occultation 2013. Yes, this was near December.
Cool.
The same year. Yeah. This is all. Not comets. Sorry. Yeah.
You gave us the whole universe, and you said that's all.
Yeah. Yeah. This is all that I have tonight. Yes. Before the all presentation that Maxi, well, Adrian, everyone. They have.
Yeah. Every presenter brings something special to the Global Star Party. And I do love to see, and Maxi, I'm glad you also showed the Star Party activity, because it's the people together with all this experience and the amazing, imagery and stories that make it all special, so it makes
in that time when we put in Facebook, well, this weekend we're going to be in this place, maybe. Who's want to come? That was in that time. Now it's very difficult because the pandemic situation and everything. But sometimes when you invite some other people that can travel from where you going to be, it's amazing, because I remember in August 29 we meet together again in Navarro in a camping area besides of the lagoon. And that was a pretty good night. I have some issues with my finger because I smashed it 3 times, and I have smashed it before in my house. It was a very cold night.
The fingers, the smashing, and the cold weather is
the worst
combination. It's the worst.
I have a cut from my of the knife. That when I was doing in the kitchen, and I cured it, but when I went there, I smashed it 3 times. Putting the tripod, and then I don't know when it was, and the other time was disarming the tripod at 4 a.m. freezing. And I remember I smashed it with all that force that I still remember the pain.
It's a dangerous hobby, astronomy.
Yes. It's for everyone, but this is the very bad part sometimes, and obviously
no way you know what the good parts are.
Yeah.
Okay.
All right, Cameron,
we are awaiting you.
Yes.
All right. Hey, come on.
Come on, Cameron.
Cameron.
All right. So that's great. I love it. It's the variety. It's so nice. It's a wonderful. Every global star party is a wonderful journey, and I really love the team here. Great group, and it will be nice. I already feel a really good friendship with all of you, and look forward to the in-person in the future.
I hope so.
Yes, we don't need presentation when we
when we see when we're going to see. Hey, come on, man! Here, hey, what's up?
Exactly.
It's going to be like this.
Yeah. It's really nice. It's really good connection. So So I really appreciate it. I would love the pictures. They're wonderful, and the stories just really cool, and great topic again, Scott. Really liked David's poetry and his stories, and of course your story. I love that one about the Dobsonian. right? The rainy, the wet Dobsonian. I love that.
You know, I was really
No,
surprised.
no.
How
This is something that I say.
Dobsonian survived.
Come on,
You know?
yeah.
Yeah.
You know,
Yeah.
we had to be with Scott in another eclipse, a solar eclipse, or and everything because he has lucky, a very huge lucky.
That's what it takes. Oh yeah. It's
So you
that's
have to
so
come
true.
to Texas. You have to come to Texas in 2024.
Okay.
Yeah. Yeah.
Yes.
So that's
For
right.
me. For me, it's business because I am explorer scientific dealer.
Yeah, you got to come
Yeah,
as the
I know,
tax
yes,
write-off. That's
Sure.
right.
Yes.
And you need an assistant, of course, to go with you. So
Of course,
Yes.
right?
Every third party is a business trip. You know?
Yeah, that's right. That's
Yeah.
right. It is.
Yeah.
That's right. Yeah, that's why we get into this business. So every star party can be a business trip.
Yeah. This is,
Yeah.
You know what's sad?
These are fun.
I will say
Nah.
this: a lot of people that get into this business lose the feeling of the magic of
Yeah.
that
Yeah.
We
beautiful
know.
feeling that you have being out under the stars and stuff. They just go, I've done too much of it. I don't want to think about telescopes anymore. But I tell you, I love it. I really do.
No, yeah, yes. Yeah. I am the same. Yes.
Right. Yeah. And
You know,
there can
when
never
I see, I don't know, a pipe tube or a very huge tube, I imagine a Newtonian or a Dobsonian. Well, but it doesn't have anything. Maybe it's a tube of gas
Right.
or something like
I know
that.
what
and
you
you
mean.
know,
You're just like, God, that could be a big telescope. You know,
Yeah,
giant
yes.
pipe
This is
out there.
when
You know.
you never see a truck with big pipes, and you say, I remember when I started to make my own telescope, I say,
Yeah.
oh, yes, PVC plastic. I can use this. Yes.
Yeah, I can use this big
What kind of
tube.
mirror? Yeah. Sorry, Cameron, use your presentation. but
Sorry.
we're
Don't be
still
sorry.
talking.
This is great.
we are Argentinians. Sorry. We like to talk. Remember that.
No apology necessary. I love it. It's great. So I'm just putting together a couple of things. So okay, let me. This is usual with the Global Star Bay. I kind of like to do things off the cuff. It's not fully prepared. I've tried to put it into some preparation, but let me just share my screen here.
Yeah.
And there's two different things I want to talk about. Let me just share my screen. First, that's obviously, is the comets. I want to talk about my experience with comets. I've had three different good experiences in my astronomy time with different comets. And then I want to give an update on Campstronomy, including for tomorrow's show, and then also the great progress I've made with flats. As you recall, last week I was sharing my new technique for taking flats. Well, I'm very happy to say that the fruits of the labor have come out, and I'm very happy with the results. So I'll share some results of that. So let's dive in. So the first, Halley's Comet, I just took these snippets. I just wanted to share this as a piece of nostalgia. Back Astroscan 2001, and this was in 1985.
I remember that. Yes.
Yeah.
Yes.
So I had this for my
Scan scientific. Yeah.
Yes. Yeah. I didn't have this one, but I was drooling over it. I was like, oh, it's so nice. I just had I didn't have anything. Actually, I had some binoculars. I had 11 by 80 binoculars, which is pretty darn good, actually, especially for comets. So I got my 11 by 80s, and the comet was in the south. Actually, it's interesting. It was just to the south here, and I remember as sun was setting in the spring of 1986. I never forget that I was just a teenager. And I had joined the Royal Astronomical Society in Vancouver chapter in British Columbia, and we went out to Campbell River Valley Park, and I never forget. I had my let me share my my screen, see if I can do this properly here. I'm going to share my, so if you can see,
okay.
I have a t-shirt actually.
Wow.
I have a t-shirt, and the Christmas before in 1985,
so beautiful.
This is actually Honolulu. My parents, I actually went to Hawaii, and this is a you know, a good old what do you call it, tourist shirt, right? But we were selling lots of these, but that was kind of a reminder to me. It was like I was trying to recall, when did I actually go, and when did I see, and when did I get this shirt? But that was that's what happened. So I actually got this shirt in December. It was, I think we were going to Hawaii in December, and then but I couldn't see Halley's Comet. It was still not bright enough somehow with the naked eye, and I didn't have any equipment. And of course, I was in light polluted Waikiki, so it was like there was no chance. But I remember getting excited about it. And then of course, when I went back home in the spring, I went out to the Scamber River. By then, the tail had gotten quite a bit longer, and that was, I'll tell you, a very big impression. I never forget, in the evening sky, this huge tail. It must have been about 20 degrees long, you know, to across the sky. So that was my Halley's Comet experience, and it's very, very memorable. And then and then the next memory I had was, again, I can't claim I've seen Comet Shoemaker 11.9, but I can claim that I've seen the impact on Jupiter. So I never saw the comet, but I saw the results of it crashing into the Jupiter. And I never forget, I just put the snippet here. It was actually July, what was it? Let me just zoom into the...
this looked like a part of
July 1992. Yeah, July 1992.
92,
and July 16th to the 22nd. And so, oops, I saw it over... Sorry about that. I apologize. When did I go here? So I actually went to. I saw this in my backyard. My yard had a very limited view of the sky, but the Jupiter was very high in the sky. So, and at that time I was older, so I actually had a 6-inch reflector and f5. And at 6 inches, pretty darn good. It gives you really good resolution and with steady seeing. And I never forget, I was following this, and they predicted when it would crash into Jupiter. And I actually saw, I never forget those nights, I saw these bruises coming out as they were coming around, and it was like,
when it was rotating.
I couldn't believe it.
Yeah,
I was like,
I remember that.
That was amazing to be able to have this predicted and planned, and then be able to go and set it up and say, and I had a clear night, and it was like, wow, you know, this was awesome. And so yeah, that was extremely. And then of course I followed that every night, and I was watching these impacts as they danced across the belt here and rotated. That was incredible. So that was my Shoemaker Levy 9, and then last one, last year I got an ED80, regular ED80, and I got Neowise, and this is through an eyepiece with my smartphone, and I was able to get a couple of these snapshots, which I was very, very thrilled, and you could see it really nicely. Even though I have Bortle 6 looking out west, I could actually see the comet in the northwestern sky. Again, also in July, so another July comet, and that was really neat. And then I have a quick picture here. This is the through my 8-inch. I just got my 8-inch a year ago, and I just did this quick snapshot of. And you can see the greenish color, just similar to the other pictures. So, so that's what aperture does for you. So you get a really good view of that. So that was really neat. But of course, so those were my experiences, and I never forget those. Let me just close that. Very memorable. And now with today's technology, I just loved the animations that Jason Guenzel shared. That was awesome. And Adrian's pictures. Oh man, just love those shots. Really, really, really nice to be able to be experienced and have the equipment and the knowledge and techniques together so that you can capture that moment and really be able to share it. That's really nice, because these experiences you can have for yourself, but to be able to capture that feeling, right, and to be able to share it, that's what's becoming more and more possible, which is wonderful. So anyhow, now let's switch over to Camstronomy. Just a quick update on Camstronomy site survey. What happened there? That's weird.
Too much Comets, security.
Yeah,
That's right.
Yeah, exactly. So yeah, we are now.
Debris.
Yeah.
So we are now going to move into Sagittarius. We've been holding off, going through Ophiuchus, and then through Sputum, and now we're going to dive into Sagittarius. There's lots of juicy stuff in here. My challenge, it's obviously in the southern hemisphere. It's gorgeous. It's directly overhead. It's beautiful. For me, it's in the Milky. It's really hard. I'm very lucky where I'm living. I actually have a view of Sagittarius, which is only just barely above the horizon. So capturing these objects visually is very difficult. And so I was very pleased though with the imager and with the filter, UHC filter. You can really eke out a lot of good stuff.
Yes.
But keep in mind that all these objects that I've highlighted here I've already done visually. Okay, so these are the ones that made the cut that are still visible even with Bortle 6 skies on the horizon. So now when I take images, they are even more impressive. So we are now, we're going to do 15 more objects tomorrow. We're moving a little bit because there's so many objects. I decided to split Sagittarius into 2 days. So this week we're going to do Northern Sagittarius, with the wonderful Lagoon Nebula, the Trifid Nebula, Omega Nebula, and all that good stuff there. And then we're going to continue with the globular clusters and the rest of the Eastern Sagittarius the following week. But basically, what I wanted to share is now. Okay, as you know, I was doing smartphone photography. Very good, I like it. But I've got my bugs ironed out, a lot of them in my imaging for my smart camera. And I've created a catalog. I'm starting to create a catalog of constellation of all my images. And I just wanted to show you a little bit of the progression here. So let me just put this in presentation mode. This is a smartphone picture of the Crescent Nebula that's in Sagittarius, not to be confused with the Crescent Nebula that everyone knows.
This is a planetary nebula.
In Cygnus.
Yes,
it's a planetary nebula.
It's planetary in Sagittario or Sagittario?
Exactly.
Or Sagittarius.
Exactly. So the smartphone, you can just start to see the structure here. This is only 8 seconds or 10-second exposure, so the limitation.
Who's the magnitude, Cameron?
The magnitude?
Maybe 8? Maybe 8?
It's pretty bright. Yeah, like if we go in here, if I go there, it's right over here. So I zoom in. So the Crescent Nebula is right here. So if I click on it, it got blocked. Just a minute, let me just move this down here. The screen is just blocking. Just a minute.
Yeah.
There we go. So let's click on it again. Magnitude 7.6. Oh, that's a double star.
Okay,
wait a minute.
Okay.
That's a double star. 10.9. No, it's actually.
No.
10,
it's actually
10.
faint. It's really faint.
Yeah, it's pretty faint, but it's pretty intense. It's a pretty good surface brightness. It's pretty small, so it's only half an arc minute square or rectangular. So almost. But so planetary nebula. In fact, every night that I start my visual observing, I especially in the summer skies, I do a survey of the planetary nebula first, because they come out really nice. They have a good contrast, and then they start to, you know, as the night gets darker and the twilight goes away, you can start to go fainter and fainter. But these there's some nice planetary nebula that I'll be highlighting as we go through the survey. But this is a good one. This is the image I took with the first time. This is back in June 20th. You can see the field curvature. You can see the you know, the graininess,
the square shape,
and the brightness. But you can see the square shape of the Crescent Nebula and some color. But I want to show you now. This is what I can do now. So fantastic. This is what I took with my flats. What I've discovered is, look at, you can get color. You can get that. You have a much better dynamic range instead of spreading your signal to noise across this wide range. When you do the histogram,
sorry, Cameron,
yeah?
is with the this one is a flats for a smartphone or for the camera?
This is all with this is with camera. Yeah, this is
camera,
with
okay.
Not with camera, with this with the Astro
Yes.
camera. Yeah, this is with the, yes.
But the flats are amazing because you resolve the entire field very what do you say, very flat is the idea.
Very flat, very even, right? So now you see it's
Very
nice and even. And then the real benefit that you get is you get a much more, you're able to eke out the signal to noise much better, right? So this is a very good thing that I've learned. And so I'm very happy with the structure you can see within this. And then this is what I took initially in June when I didn't have the flats figured out. You can see the corners are big netted or darker, and you know, it looks nice. It looks pretty good, but it's still, and this is even worse. I thought, okay, what happened here is I actually got a longer my extension tube, so my back focus was proper, but what happened is it made the field curvature much even worse. But just as a reference,
with 8 inches,
this is all with 8-inch, 8-inch Mikasa green.
8 inches. With a huge. Yes, with the extension tube, have a big netting very hard.
Yes, but it's the big netting can be completely removed, because look at this.
Yeah,
this is now with
you
a
make
flat.
a very great flats.
It's a really huge difference. So you can now pick up all this fainter nebulosity even over here, right? And this is not even what I've done is I've done live stacking with all of this, so it's kind of pre-processed, if you will. So I'm not taking this offline and doing any image processing. This is just the live using the ASIR Pro's algorithm to load the flats on top automatically.
The system of the screen work properly. The white screen.
Yes. So now here's an example of the Trifid Nebula. Again, you can see the nebula. That's what I showed before. You can see the curvature. This is what it looked like now.
Oh, yeah.
So
another thing. It's another thing.
Yeah. And then finally, Lagoon Nebula.
Yeah.
You can see, you know, and then look at this.
Wow.
Right?
Oh.
So huge difference.
By doing the flats.
Just by doing the
flats. And
I'm so happy when the flats work properly.
Yeah, you gotta get the flats. You gotta get the flats. Yeah, you gotta. I can tell you that is the wow factor. I mean, when you get the flats, you can say reliably you can get reasonable shots. You know, that the biggest thing it gives is you can see the dynamic range. All this nebulosity gets lost over here. You can see it, but it doesn't have a good signal to noise.
Yes.
Whereas here you really pick it out.
An AIM-8 or Lagoon Nebula is a weird shape that have because how do you say, it's limit. I'm sorry with my English. It's limitada. Limited. It's limited.
Yes.
Very, very strongly. And sometimes when you process, you don't know exactly where is finish and start. If you don't have a great flat, it's a nightmare to know where is dark and where is the light of the nebula.
Exactly. And to be able to discover this myself, and then for everyone else who's out there, when you discover this yourself, I can highly encourage you, make sure you get those flats.
Because, yes.
The flats are really, really important, and they're going to make your enjoyment so much better because you're going to get much more predictable and reliable results. And that's extremely important for me. Doing the sky survey, now I feel that I can start to take all the pictures, and they're reasonable, they're good enough quality. I can obviously refine it, right? There's more tweaking to be done, but at least for the sky survey purposes, I can get decent pictures and have really good resolution and clear results, right? So it will be with not as much post-processing effort, right? That's my goal, is to try to do as much pre-processing and get all the setups so that when I do take the picture, I'm getting good stuff, and then that way it makes it a lot easier to handle all the data afterwards.
Yeah. Yes.
So,
absolutely. Yes.
Yeah.
I can feel your happiness.
Yeah,
I know.
It's like you've gone like this whole new level, so it's really cool.
Yes. When the things works, and when you show us last week the system that you choose, that I think that is perfect. The screen and the blanket.
Yeah.
Come on. Yeah.
Here's another one. Here's M22.
We'll be adapting this system. Wow.
Yeah. So this is M22, and then now look at how M22 looks. Right?
Wow.
So isn't that nicer? But you'll notice there's a new problem I'm having. You see this dark line here?
Yeah.
I'm having some banding issues, so some other noises coming through, so I have to figure that out. But that's
you might be able to, are you using a bias frame here or not?
I am. I'm using the 100, but I've been trying different things at different temperatures, Scott, and somehow there's still these bands showing up. So I need to do some figuring out here. But it only shows up now because I found out that you cannot just apply flat planes without using bias. You have to have bias. In the ASI live stacking, it mandatory that you have a bias with the flat.
Yes.
So I select both. I've got 100 biases, and I've done several sets to try to get rid of this noise. But unfortunately, I don't know what's causing that, and it's something I can work on. But yeah, that's the next thing. But at least I'm just happy that I got to this stage where we got a nice flat picture.
Yeah. Yes. It's great.
And the side bonus, like I say, since I'm just having so much fun, this is okay. Let me just show you. I took Andromeda Galaxy last night. So this is Andromeda Galaxy, this core. So I was able to get the dust here, and just because the flat makes it, you can really see now the difference between where the galaxy is and where the background is. So I took a couple of pictures of including the outer arms. Obviously, I have a limited field of view with the 8-inch Mikasa, but you get a really.
Sorry, Cameron. Who is the size of the sensor?
It's a 294. So it's I'm using the 6.3 focal reducer. So the focal length is around 1280, and the sensor pixel size is 4 point something microns, 4 point something.
Yes,
so
yes. You need 3 pictures for Andromeda Galaxy.
Yeah, exactly. But I just wanted to see, because I wanted to see these multiple dust lanes, because visually in a larger telescope you start to pick out this first dust lane, and if you're in a dark sky you can start to pick out the second dust lane. Mm-hmm. So it's nice to be able to image that in my own backyard. with light polluted skies and still get reasonable. And here's the other thing I learned. Yeah, now that we're talking about this, I changed filter. I have 2 different filters. So let me just, since we're talking about it anyhow, let me go to my. It's probably here. No.
Let's see.
This one here.
There's some nice comments here. Harold Locke, I'm bino scanning tonight. Hazy, tons of
it's
summer.
not good.
You got people doing
good.
astronomy while they're listening to the Global Star Party.
Awesome.
Cameron is not cool at the camera.
It's not even cool. Yeah, exactly.
No, you're crazy like Maxi.
You're crazy like
We are watching.
That's a compliment. I take. That's great.
Can I solve tomorrow a cooler camera? No, people say no.
Harold Locke said that's awesome, even better than the Sky Safari images. Yeah, it's nice. Harold said, can you just adjust the black slightly and blend the black together just a touch, so.
Yes. No, I played with it, and I actually intentionally lightened the sky background. So if we go to one of the, I actually like to have it a little bit light because it is already light polluted, but let's go to this one here, the Lagoon Nebula.
It's a great camera, really.
So
the
this is pretty dark. I can play with it and make it darker. I've done some stretching. So what I do when I do these snaps is I actually, if I go to the raw data, so here's how I can find out. So I know I took it on 7/11 at 1:30 in the morning, or sorry, 12:30 in the morning. So 7/11, this would be this night. And then I can find out which. So I had a couple of snaps. So here's 2 different stretches of the lagoon. So one, this is where I left it bright, and then the next one is I made it darker. But you see, even this, what I do is I copy this. It's sharper, and but you kind of play. And there's another little technique I want to show you guys. Now we're on the topic. Is if I go and I paste it, let's just make a new picture here. So I'm going to paste this. So this is what it looks like, but there's a little technique in PowerPoint. It's called correction. So this is my cheap Pixin site. So what you can do is you can play around with these, and this is a combination of contrast and brightness. So you can either brighten the image, or you can darken it, and you can play with that. So I just do this to give me a quick and dirty, reasonably good picture. It takes so I do my stretch, and then I do my screenshot. And I don't play with, at this point, I don't play with TIFFs or individual stacks or darks or frames or any post-processing right now. That's going to be saved for later when I have time and I choose some objects that I really want to dig into. But for now, to be able to do this and do some quick, image processing on the fly is really, really good for the workflow, and then be able to enjoy it, get some good pictures, and then, like I say, with my sky survey, continue to go in and then give a broad brush. I guess the analogy I'd make is it's like a painter, right? I'm painting the sky. I'm painting the sky with a broad brush, and there are certain areas that I'm coming back to and working some details on. And then I might pick some areas and say, maybe this particular planetary nebula, I realize I need to use a smartphone because it has a better image sensor, and I can zoom in with an eyepiece to get a better resolution because it's too stellar in this one. Or there might be a galaxy that I don't want to use a UHC filter. I want to use my IR cut filter and then take a broadband picture and then do some stretching on it. So I'm learning a lot of different things along the way, painting techniques, I guess you could say. And then I can always fine tune it. And as I get more tools in my easel, I can start to refine it. But I'm just really loving this.
Yes,
you can start to see the nebulosity and all these little nodules, and
the
some of
details
the.
are really good.
I'm really pleased with being able to pick out some of these dark nebula, some of these little, I guess, ionized sections that are.
Do you have good collimated your telescope?
Yeah.
Yeah. So it's very enjoyable, and you can even see when I did this stretch, you can even see a little bit of the greens coming out. It's not pure red, so you can actually see a little bit of different color in the lagoon. So yeah, so that's my little update for today. So a big part of this is, I have a lot of data, but I'm trying to organize it into a logical way so that when we get into this catalog that I'm building for the Camstronomy catalog, it's going to start to look like I'm going to have a history of all the different images and the progression, and then I'm going to choose the best one out of each of those objects, and then you'll have per constellation. You're going to have every single object that is in the Camstronomy Sky Survey. So in this case, this is Sagittarius, and these are all the objects in Sagittarius, and then I'll have images for each of those. But I have to admit, I am now becoming immersed because of this flat technology that I just applied. I'm becoming very much immersed in focusing more on astro camera, dedicated astronomy camera at this point for my imaging. But I do realize that there are certain objects as I'm going through that I will actually go back and use a smartphone, as I mentioned, especially the very small planetary nebulae that need a better pixel size. I'm going to go back and read those, because you remember that picture of the Cat's Eye Nebula that I took, for example, with the smartphone back. That really, if I go to that one, I don't know if it's probably not in here. Yeah, sorry, I don't have it handy, but basically that one really benefits. So what I'll do is I'll do the broad brush with the dedicated astronomy camera, and then refine techniques. I want to say one more thing. Filters. So going back to here. So I have two filters. I don't have a filter wheel, but I go outside and it's like, okay, I'm going to, oops, sorry. I manually say, I'm going to go to the galaxies. If I'm in galaxy mode, what I discovered, I tried galaxies with the UHC filter, and it tends to make them a little bit more yellowish tinge, which is an interesting byproduct because it takes out the green. Because galaxies are broadband, right? They're across the spectrum. So I found that you can pick out the galaxies with the UHC filter. It reduces the noise, but it's a more pleasing picture if you can do it with a broadband. So I tend to now, in my sky survey pictures, I go back and I'm using just the IR cut filter for all my galaxy images, and a globular cluster, any stellar or star clusters, and then any nebulosity. Yeah, you got to use the UHC like for the veil, the cocoon, and all any of those guys. As you saw with the lagoon, it just pops. The UHC just really makes it so when you do that stretch, all the details come out. So it's very, very good. So anyhow, I've kind of rambled on, but thanks very much, guys. It's really cool to be able to share, and I hope, I hope that we have more and more people that are going to be able to, follow this journey, right?
Right.
Yeah.
Right.
Really, we enjoyed your work because your progress is amazing. From 1 week tell us
Another.
we are trying this, and this week we have the results and are
Yeah,
amazing.
that's good. Yeah, you've taken a very careful approach and really executed it very well. So
Yeah, something that is so difficult. Have a great flat with the Schmidt-Cassegrain telescope. I worked 30 years with a Cassegrain telescope, and really know that in anything that you put like extension tube or anything that only the size of the image, when you use a larger T adapter, you have a bigger size of the image, because the secondary mirror is like a Barlow. When you have a longer distance, the size of the things are, do you have an effective focal length larger than the native focal length.
Oh, yes. Yes, because Barlow is different than a teleextender, right?
Yes, for example.
Yeah.
I remember.
Yeah.
Yeah, I don't remember where I have my Science telescope with a work of a guy to calculate. I need to find this, because it's very great to have the formula to calculate from the rear side to the distance where you point your sensor, and you have how many times you are using a larger focal length, because it's not the same. Your Cassegrain is f10, but when you use a larger accessory for astrophotography or visual, but you are going with a longer distance, you have a magnification bigger than if you use a shorter or low profile T adapter. Not everybody knows this, and it's of course that it's not a great difference, but it's something that is another thing of the Schmidt-Cassegrain telescopes that is different, because you're focusing, moving the primary mirror. It's not like the Richie Gretier telescope, where you're moving the sensor to put in the focus. This is a real distant focus. In Cassegrain, you are changing all time.
Yes.
Yeah, you have an f2 primary, but then that's aimed at a 5 power secondary. And then when you move that mirror, you're changing that back focus a lot, so that's what makes it so versatile, is that you can do that. It does have its challenges, though, if you have a mirror that's moving, because you can get image shift or mirror flop, these kinds of things.
The focus.
So these are some of the things that people with Cassegrains have to deal with, but there is technically no perfect telescope out there. You just learn how to use the tool, get the best results out of it, and apply it towards imaging within the best way, so.
The other thing I learned just the other night, a couple of other tips. When you do live stacking, let's say of 10 seconds or 30-second subs, what happens is, if you have a gust of wind, like we've had some fairly hot days here in Seattle lately, and then in the evening it changes, and then that creates a bit of gusts that come. That will shake. I still put a dew shield on my scope. That creates a little bit of vibration. So what happens is, it's very frustrating. There's some nights where there's if you do live stacking, what will happen is you'll see it will start to blur the shots. You'll have a really good like 9th stack, and it's like, oh, the 10th one, it jiggled. It's like, oh, so you have to start it all over again. Whereas if you take individual, right, and you process it offline, you can manually take those out and say, okay, I don't need that. You can throw them away, right? So you can save the individual ones. So that's, I'm learning about those limitations as well. I like the advantage of live stacking because you do all the pre-processing there. However, it's risky if you have a windy or gusty time, because all of a sudden one frame comes in, you ruined your whole live stack. So that's an interesting little nuance for anyone. So you can try different techniques with that to be able to filter out the bad data. Anyhow,
Yes.
yeah. So and then the other thing, another thing I discovered is my Wi-Fi was dropping out on my. I was really frustrated every time, and I can tell you this now. Every time I would track an object at 60 degrees as altitude, 60 degrees.
60 degrees, yeah.
60. As soon as it's above 60, it drops out. And I didn't know that until I started seeing this, because I was taking pictures of Cygnus, the Veil, and all those that are just moving up from the east. And guess what? As soon as it tracks past 60 degrees, it drops out. And then I'm wondering, there could be, I'm just sharing this with you guys. This is fresh off the press. I know now that this is always happening. It happens reliably, because I'd be out there and it'd be really frustrated to have to do a realignment at 1 o'clock in the morning, right? So
Cameron, you're talking about the AC altitude AC mount of the evolution.
Yeah, this is the evolution, Nate. Yeah.
Yes.
Yeah.
Yes. You don't have no more than, if you're lucky, 25 minutes of tracking for a single shot.
Oh no, I can't track any more than 30 seconds because of the field rotation, right?
Yes. How many time do you use in a single shots?
So what I do,
rotation is a real thing. Yes, I know.
Yeah. So what I can do is like, you can start to see, depending on where you are with relation to the rotation. If you're facing the horizon to the south, you're not going to have much field rotation. But if you're facing to the southeast, that's the maximum field rotation, right? Because now you have to move both alt and azimuth to compensate for the Earth's rotation. So what happens is when you're it does a lot of. So I found that you can't even take 30-second shots sometimes at certain because you'll see a jag. It will do an adjustment, a periodic correction, if you will. But what I can get away with generally, if I'm in either facing east or in general directions, I've been lucky. I'm limited to pretty much 30 seconds. But to your point, I can stack, because what it does is it does the rotation, it does the adjustments in between, and the stacking algorithm can do the plate solve. And then what it does, it rotates the image, and you'll see the corners are actually black. So it starts. You'll start to see the as I take multiple. I've taken up to 20, 30-second. So what is that? 10 minutes, right? 10 minutes of data.
Yes.
That's the maximum I've taken, and then you start to see, some clipping on the side. But it's the center of the image and the surrounding. Now that I have flats, is still okay.
I know, because I used it a lot of time. Evolution 9.25.
Yeah.
I took a lot of pictures of galaxies, Orion, and a lot of things. And when I started to use equatorial mount, I say never more. And
I'm not going to go back.
Actually, for me, I'm preparing a very weird combination, because Explorer Scientific sent us to our company, of course, for selling. We choose something that is the the OTA, the optical tube assembly, it's a Maxutov of 5 inches Maxutov, but it's F15.
Yes. Yes, exactly.
Very planetary.
Yes. Explore Scientific chose this very large focal length, because many brands chosen for the manufacturers maybe F10, F8, but if you like to have a great Maxutov Cassegrain telescope, you need to choose a larger focal relation, because you have a flat field. First of all, you have a very low comma if you have a 15 F relation, a 15 F number. Second one is that you don't have many people think that 15 relation is very large, is very low for photography, and this is not real, because all that you need is aperture. Well, you, me, and Maxi, we think in of course Scott, we think in numbers for astronomy, that light gathering is everything in astronomy.
And resolution.
And people say, 15. Come on, but have
the aperture, you get higher resolution.
Higher resolution,
more light gathering,
contrast. Yes.
So, and what you do with the focal length is a matter of image scale,
Yes. Yes. Well, honestly, being a galaxy lover myself, everyone talks about Maxutovs being planet killers. They're awesome for galaxies. I mean, you could put a long focal length eyepiece in a Maxutov, right? Which will still give you higher power, but you don't need a Barlow, right? You can still get excellent contrast. It's gorgeous. I mean, I discovered that I have a little 4-inch Mach 102, and I'll tell you what a workhorse. I mean, it's a great little scope. It's very small, very portable, and but the biggest thing it's not as, you have to be experienced, because you need to have something, because it has such a limited field of view. Finding objects is the issue. Now, so if you have a go-to, if you put it on a go-to, now they have these small go-tos like an IXOS 100, or then basically you can now you've solved the problem, and these Macs are really awesome.
Yes, you choose the facility of use a sky map to drive the telescope over another system to found objects. It's understandable, yes, and maybe because your objective is not only astrophotography, if not make a catalog, and an alt-azimuth mount for this offer a great solution. I understand.
You need both. I mean, you cannot replace a wide field. I want like an ED80 type.
Yes,
you cannot. That's irreplaceable. You can scan the skies. It's so enjoyable, and your photos are great. I can't wait to start imaging with an ED80. I'm really excited for that one. But then you throw it, to me, it's like another eyepiece, right? You get a Mac, so you don't have to have a Barlow, right?
Yeah.
And then you have another eyepiece. It's another tool, right? So you can now have both. You can have the long focal length and portable, and then you also have the short focal length wide field. So really good complementary scopes.
Yeah. It's something that when I am in a time of my life, like telescope dealer, it's fun because I am in a time of my life where I'm really, before 30 years to sell telescope to the people, to offer people to make a. I'm think more in. This is the OTA. This is the mount. This is your software or your system. This is the eyepiece. It's impossible to sell one telescope like a one piece because the technology, well, the cameras you have, and it is anymore only for kids, for starter kits, for kids or for people that know, but only just in the second stage of your hobby, you need to choose a mount, a telescope, an OTA, only the optical tube, a camera, all from different manufacturers or from the same manufacturer, but in the different models.
Yes.
This is, for example, actually, we are preparing a telescope that starting to choose. Scott, who is the video of the Mac? I forget the name of one of the support technical support that make the video and say show the Mac over the Nexus 100.
Kent? Is it Kent?
You're talking about one of our customer service representatives?
Yes.
There's Chuck, Ross, Tyler.
Tyler, I think.
Maybe Kent.
Yes. I started to see this and say, okay, first of all, it's a great combination of size and weight between the mount and the OTA. First of all, you think between size and weight. The first thing that you think when we choose the mount, the mount and the OTA. But second one, I say, who is the focal length of this tube? And I say, okay, it's near to 2 meters. I say, is the focal length of a Cassegrain 8 inches? And maybe do you have some advantage in this because do you have a more stable opticals of course it's smaller diameter, but I think that have, for example, you have native focal length longer, and today do you have, for example, something that in the past was impossible to make in a lightweight I forget the word, sorry, in English and in Spanish. At this hour, it's terrible.
It's okay.
Yes. El armado, como que el armado. Assembly. Yes. And today, the mini guide, the scopes, the cameras are really small. And you can start to use for a small mount, a quadruple mount, go to a quadruple mount, and two with large focal length, with a system with a guider, and maybe I think that can have something like unexpected results. Of course, that I'll try it, and I started to make pictures in 2 weeks, I think. The OTAs are coming to Miami. I need to prepare.
Okay.
Deliver to Buenos Aires, and when I start to talk with people, with all people that make astronomy with many from many years, I say, oh, okay. Oh, what is the focus? 2 meters near. Okay. Well, it will be very interesting to.
Yes.
Yes.
I recall astrophotographer Jack Newton, and he started using Barlow lenses to photograph galaxies. Okay,
Oh.
so he had his 16-inch f10. Okay, 160 inches of focal length.
Yes.
A 2 times Barlow to photograph galaxies, and the image scale was fantastic. It looked like galaxies taken with some large professional telescope, because he would photograph this side of it and that side of the galaxy, and he's mosaicing them, and it was really amazing. A lot of work, okay, but still, that larger focal length gives you the kind of image scale, especially if you're matching. You got the right sensor and you're matching that.
Yes.
Apex. Yeah.
Absolutely. Absolutely. Yes.
Well,
But
gentlemen,
you gotta have a good mount. You gotta have a good mount.
Gotta have a good mount. Yes,
You gotta have
You
you gotta have a good mount. I was looking at those 16 inches Meads when I was younger too, and I those were always the show telescope in the store.
Yeah.
I remember drooling over it in Anacortes telescope. There was a big, beautiful 16-inch white Mead McCasley sitting there.
Right.
It weighed 400 pounds. But
Yes.
I think it's 400 pounds, right? It's 200 pounds for the mount, 200 pounds for the
the tube assembly with the deck bearings was about 125 pounds.
Yeah.
Fork arms were hollow, so that was about a 40-pound piece, and then you had about a 75-pound drive base, and then you had the tripod or a pier. If it was on a pier, the pier was usually filled with sand, so there's probably over 400 pounds.
It's huge, right? It's like, but I remember that there was like, but yeah, I mean, I was actually looking at that, and then I said, no, I'll go for a Dobsonian for now.
Okay.
But you have to say, if you can do it, the mount is, it doesn't matter. Then you can throw on just to Caesar's point, you can throw on any telescope. You get a good mount. You can piggyback them, and I cannot say enough about how important a good mount is.
Even without a motorized mount, you did the Crescent Nebula, the planetary nebula, and reminds me that Nico Arias he did some observations without a UHC filter and with a UHC filter, and also take pictures with the planetary camera using a UHC filter and RGB filters. Let me show you a little bit the screen. This is the draw that he did, the observation without the filter. You see the stars, and
UHC.
Yes, and he is with the UHC filter. It pops out a lot.
Yes,
and this, let me here.
Perfect.
This is the picture that he did of the planetary Crescent Nebula.
Oh,
wow.
Let me, no.
Oh yeah, look at that.
Oh yeah.
With only the Dobsonian flex tube manually and the QH Y5 monochrome camera.
No. Yeah. Nico, the hammer is a crazy man. Yeah.
Yes, he's a crazy man. He's from Bienfield. He's in the south of Buenos Aires.
Yeah.
He's from here. The great Buenos Aires.
Hey guys, Scott. Agustin Agustin became here to the after party because he's starting to listen and say he couldn't be outside.
That's cool.
Good. We haven't seen your son in a long time. So, yeah.
Yeah.
Un abrazo, Agustín, che. Un gusto. Did you screen the goals Saturday?
Yes.
Yes.
Oh yeah.
Yeah. Oh come on. I'm not mad of
that was awesome.
Shouter or celebrator, but yeah.
Yeah, that was a big one.
Yeah.
When was the last time? It was like 15 years, or what? It was like it was a milestone, right, for Argentina versus Brazil.
No, there was too many matches against Brazil, but I remember in 2004, the finale of the Copa America Cup, we lost. And then again in the finale, in the Chile Copa America, and every time, and of course in 2004.
Why do you remember me this? Yeah.
No, he asked.
Sorry about that. Okay.
No, but that's past.
It's all past now. Yeah, exactly. Yes. That's great. I'm really happy for you guys. When I saw that, I was thinking about you guys. And I was like, yeah, that's really cool. That's really cool.
Yeah, you know.
Gentlemen, I think it's that time. I think it's that time. There's a few videos that I did. I didn't run yet that I'm going to run about comets. So if you're still watching out there in the audience, I think there's a couple of comments here. Harold Locke says here, I've been playing using binoculars lately, and last time was using my Celestron 5-inch Maxitov Cassegrain, 1500 millimeters, and I was so bummed that I was not gathering enough light to view through the haze and pollution. You are now letting me know that it's my ability not to be able to find the target because of my narrow field of view. Even though my finder scope was centered perfectly, well, I usually use point and go to make the go to. I usually use point and go and not the go to ability. So I don't have to take a hammer. I guess he realizes but he doesn't have to destroy his telescope.
It's a beautiful scope.
Okay.
Yeah,
you do have to point it very carefully.
Yeah.
Because
there's
of
a
the focal length.
40 millimeters eyepiece for.
Yeah. Use the longest focal length eyepiece you can to get started with, and sometimes it is easy to miss when you're up at those higher magnifications.
You have to have like 3 types of focal lengths for the finder.
Actually, if I reflect on all my
middle one, and almost closer to the main telescope.
No,
it's either that or you do a perfect alignment.
If I summarize all my frustrations, all my experience using equipment has been because of not a good mount, and not a good mount, and too narrow a field of view for the mount.
Yeah, it's a deadly combination.
Deadly combination.
It's a deadly. You can get away with a bad mount with a wide field telescope, and it's fine, right? It's very forgiving.
Yeah.
But you have a narrow field telescope, and it goes back to the old department store telescope, like your one that you have in the corner there.
Really long focal length.
Long focal length and very bad mount. The worst. That is the number one. If you summarize, then finally, if you have a short focal length telescope and a bad mount, it's okay, but the mount will still bug you. If you have a really awesome mount and a crappy telescope, guess what? It doesn't matter. The mount will make the bad telescope actually really perform well. Yeah. Because you can have a better experience because you'll point it, it will move nicely. I cannot. It's a hard thing.
For a lot of
to
beginners,
get over.
this goes totally against what they're thinking or what they're wanting. Because they want this
there is
amazing big telescope, and they'll go and put it on a small mount. And and this forces manufacturers also because this is what is the forces of driving that kind of thing.
For Agustin,
desire, so.
This assembly, I give to Agustin 1 unit of the XS100, the Mac, and guider, of course, all complete. We are awaiting how quality of pictures he can do it.
As long as they're in the city.
Yeah.
Cool. All right. Sorry, I extended it again. Sorry, Scott.
It's okay. Okay, you waited all night long to give your presentation, and you know,
okay,
you had a lot to say, so that's very cool. And it's, I mean, and we have these guys from Argentina to hang out with us, and I know the sun is coming up down there. So.
Yes, it is.
So let me ask you, Caesar and Maxi, you know, I remember going to Spain, okay? And you know, for us in the USA, we want to eat dinner like at 6 or 7 o'clock, you know, and maybe we'll stay up till 10, 11, 12, and then we go to sleep, right?
Yeah.
But in Spain, no, they go to work at 8, they get off at 12, they're at home till 4 o'clock in the afternoon, then they go back to work until 8 o'clock, and then they go home again, and then maybe midnight they go out and eat. Right?
Yeah.
Is it like that in Argentina?
We have dinner at 11.
Here in Chivilcoy, it has the commercial in the shops and commercial stores have the town time, you know, start 8 a.m. to 12, then goes to your house, you sleep a nap maybe, and then you return maybe 3 or 4 p.m. to 7 or 8 p.m. Then when you come here to your house, give something to eat, but maybe 11 and 12 you're going to dinner, and then you maybe, well, here I'm going to start to editing or see a little of TV, and then I'm going to rest to wake up again to 7 a.m.
Actually, you know, it's interesting. You know, my first experience of that when I really hit home was I was in traveling to Malaga, Spain. In the southern part of the Mediterranean, and I remember we were going out it was like 7:30, 8 o'clock. We were going saying, hey, let's go grab a bite to eat. It's late to eat, you know, let's go. And we walk by and it's like there's all the restaurants. They look like they're restaurants, but they had all the doors were closed and it was like everything was shut. I was like, what's going on? And so we just kept on walking. And we watched we walked along the beach, and then we went back, and it was around 9:30, 10 o'clock. Everything was open.
Now
everything was like totally open, and everything's like okay, now they're started. It's like okay, it's like it fully came alive. It was completely dead, and then now all of a sudden it's like they're open for business. It's like wow. So that's when already, and then they told me all the local Spanish guys that were saying, this is we start dinner at 9 o'clock.
It's like Spain or in the south of Italy. Here in Buenos Aires, for example, last year was totally different. But normally the very pubs or they close when the people go out in the week, not in the weekend. Maybe the week.
Not on the weekend.
Maybe it's Wednesday.
People's going out. Maybe at 2 a.m. Do you have open?
I think the day they work the most is Thursdays, which is
though.
It's a crazy.
Not crazy. Just different. Yeah, but I did enjoy my time in Madrid, and you know, I have not been to Argentina, but I've been to Uruguay. Brazil.
No, it's the same.
Uruguay, yes.
Yeah. I love my time in Uruguay.
I have a lot of friends in Uruguay, and it's one of the places where my kids grow in our vacations. It's Uruguay.
There's an old high school. It was a science technical high school. And they have in there a beautiful Zeiss refractor.
Wow.
Zeiss refractor. I think it's like a 8-inch, something like that.
In South
I can
America,
show you a
especially
picture.
in Argentina, Uruguay, you have a lot of Zeiss refractors that the same that I'm restoring.
Yeah, check this one out.
18 centimeters. Maybe they have the same model in Uruguay. I think that yes.
You know, Cesar, in Luján, there was the castle. It's a property, a private property that has an observatory, and I thought, and I heard that has a telescope.
Montevideo
Montevideo,
National High School.
Sure. Yes, the National School of Montevideo have a size similar, the same model that I'm restoring now.
Wow.
Okay.
You know, because the cell with the achromatic objective that I disassembled for the San Miguel Observatory is the same that they had in Montevideo and Luján. Luján is a private. Yeah.
That's the telescope. I mean, it is so perfectly maintained.
Wow.
It looks brand new.
It looks like you, Scott.
That is me.
Yeah.
That was beautiful, though. This is
I think that is the same kind of telescope that we are. Yes, it's the same telescope, Scott. It's the same telescope because it's a model of maybe for 1920s, and it's an achromatic refractor. Montevideo and in San Miguel, they both the same model, and it's impressive. I show you in a presentation the cell with the objective because we needed an entire evening 4 hours to remove because any screw was unable to remove without broken.
Yeah,
it was very rusty.
Yeah,
absolutely rusty. My next step with this is, first of all, I don't touch the something that is very important is we are awaiting the signature of the state of the government to give to the municipal. I don't know who is the majority. Maybe when you have a small city like San Miguel, to give to the majors to have the property of the observatory. It's very important to start to restoring, to move, to repair, because we disassembled only to keep in a safe place, because like they are making a street in this moment, the observatory can be more vandalized like now. And I the first thing that I say, okay, we need to remove so fast as possible.
Yeah.
The objective to keep in a place in a safe place the cell, because the entire focus system that you show the same, because I have the same picture, was totally stilled or
oh yeah, it's like frozen. You can't adjust it or
they
move it,
remove
right?
all they rob stolen was totally
yeah. Wow.
Really we need if somebody in the United States have the same or because really we are searching for donation in the future.
So you need to Cesar, you need to talk to John Briggs.
So John Briggs, yes,
John Briggs,
maybe
he's on our show a lot, and he has the Astronomical Lyceum in New Mexico.
Yes,
and he has many telescopes and knows where to find.
Yes, maybe we can. We can. We don't have problem in adapting because maybe the diameter is a little different, But I think that he showed a similar part of a side telescope, because in many places it's very important to be connected, because many people have the parts that maybe we have two parts that in another part of the world they have one, there are, and my idea it's you can see, Scott, that the picture that you are with the size, we have the same equatorial mount that was vandalized too, and we are thinking in make with 2 strong step motors, adapting a PMC8.
PMC8, yeah.
Yeah,
Start down that path. We will help you. Yes.
Yeah. Yes.
We'll help you.
The idea, I talk with the people that the system is very flexible and very adapting for a lot of different software, and it's open source. That is very important for that is like the idea is very center of education. If we have open software, we can do this for students to collaborate and make code. Code, it's very important.
I would love to see that project get started. That would be great. To control larger stepper motors, we can do it. There may be some additional electronics to drive a big motor. Okay, but yeah, we were looking at the possibility of driving the 40-inch Yerkes refractor, which is a giant.
Okay, huge. Yes.
Telescope.
Huge.
I had Jerry already thinking about how we would use the PMC8 electronics to drive that telescope, and he said, "Yeah, it's possible." So, but at 8-inch or 10-inch refractor, yeah, sure.
Yes, I know, because I know that you made this for the Yerkes refractor. This is why I think that you can help us with this.
Yes, we can.
Yes,
we would be happy to. We'd be happy to.
Yeah. Thank you, Scott.
That's cool.
An excellent start party, really.
Thank you. Thank you. Well, you guys made it an excellent start party. Thank you. It was awesome. And for all of you that are watching, our next Global Star Party will be on July 20th. Our host is Caitlin Ahrens from Goddard Space Flight Center, and it is the anniversary of the Apollo 11 moon landing, and so we'll have a number of people on that are experts about the moon, and it'll be an exciting time. So thanks for watching. And again, I have a few videos, some Comet videos I thought that you would find interesting that I'm going to run next. And you guys, Caesar, Maxi, and Cameron, thank you very much. And for anyone else that's watching that was a presenter for the show, thanks again. And you guys have a good night, or good morning as it might be.
Thanks, Scott.
Take care.
Thanks, Caesar. Thanks, Maxi.
See you guys.
Ciao.
Bye-bye. See you, Maxi. See you, Cameron.
Yeah, see you.
God. Thank you.
Every 5.4 years, Comet 41P swings around the Sun and puts on a show for observers on Earth. Between March and April 2017, as the comet made its closest approach to Earth, astronomers caught it doing something never before seen. 41P is an icy body from the Kuiper Belt, the cold storage zone beyond Neptune. Neptune's gravity first sent it hurtling toward the Sun, and Jupiter trapped it in its current orbit. As it nears the Sun, the comet's icy areas warm up and turn to gas. This forms jets that blast gas and dust into space. This material becomes an extended atmosphere around the comet and makes up its tail. To better understand how comets work, astronomers study how these jets change as a comet approaches and departs the inner solar system. From this, astronomers can measure how fast the comet rotates. When 41P approached in March 2017, astronomers found it to be rotating about once every 20 hours. But when NASA's Swift studied the comet in May, 41P's rotation period had more than doubled. This is the largest, most abrupt rotational change ever seen on a comet. Comet 41P is a small object, smaller than most of the so-called Jupiter family comets, and very active. Astronomers think a particularly strong active area produced jets that lined up in just the right way to suddenly put the brakes on the comet's spin. Extrapolating from the swift measurements, 41P could have continued to slow in the following months, spinning less than once every 4 days by summer. This spin is too slow to keep the comet stable, so even small jets can set it wobbling like a top, or tumbling, and ultimately rotating around a different axis. Such changes affect which parts of the comet are exposed to sunlight. Perhaps this will drive new levels of activity that will further change the comet's spin. Scientists have never before observed this phase of comet evolution, and they look forward to 41P's next visit in 2022.
Last summer, an amateur astronomer discovered the first interstellar comet zipping through our solar system, 2I Borisov. It was clear from its path that the comet would dim from view within months, so scientists were quick to turn their telescopes towards the alien comet for a view. Among them was an international team led by NASA Goddard. They used the ALMA telescope array in northern Chile to probe 2I Borisov while it was close by. Inside the halo of gas around the comet, they detected something peculiar. 2I Borisov was releasing a higher concentration of carbon monoxide than any comet observed at a similar distance from the Sun. NASA's Hubble Space Telescope later confirmed this too. Scientists wondered, could this be our first glimpse of the chemistry of another planetary system? Or are we learning that there's more chemical diversity among comets than we knew of? Carbon monoxide is one of the most abundant molecules in space. Scientists expect to see it inside all comets, yet there's a huge variation, which is puzzling. Regardless, 2I Borisov is off the charts. To preserve its carbon monoxide, the comet likely formed very far away from its star in one of the coldest environments known. In our solar system, this would have been in the vicinity of Neptune. When comets were forming, temperatures there could have reached negative 420 degrees Fahrenheit. Scientists think that gravitational disturbances from young, jostling planets may have thrown 2I Borisov out of its home star system and onto a cold, lonely voyage. Our solar system is tiny compared to the distances between star systems. It's incredibly rare for an interstellar comet to pass within observable range. However, big, sophisticated telescopes are coming online, so scientists expect to see more alien comets like 2I Borisov. Will they all be similarly exotic?
Hi, I am Carl Battams. I am a computational scientist and astrophysicist from the Naval Research Lab. Everything that you're seeing in this movie is based on actual data. So actually, every single dot that you see in this movie is a real comet that has been discovered or observed by SOHO. SOHO is the Solar and Heliospheric Observatory, so it's a joint mission between NASA and the European Space Agency. And SOHO's mission was to study and understand the sun and the region of space surrounding the sun and all of the cool, awesome, explosive stuff that the sun does. There was never any intention for SOHO to be a comet discoverer. The reason that SOHO has been so successful at finding these comets is because it's got this wonderful instrument on the spacecraft that offers us a view of the inner solar system that we just cannot get from any telescope on Earth. The different colors in this movie represent different families or populations of comets that SOHO is observing. So the red comets, these are Kreutz sun grazers. The green comets are what we call Maya group comets. The only exception is the yellow ones that you see. These are what we call non-group comets. These do not belong to any family. You see as these objects are flying in towards the sun, they're not really going in a straight line, they're following a curve. And that curve is because of the sun's gravity. And the closer a comet gets to the sun, the faster it goes. And then they slow down again as they move away from the sun. One of the really awesome facts that I love about the sun grazers, in particular the Kreutz comets that you're seeing in red, they are the fastest objects in our solar system that aren't particles. They get so close to the sun that they're traveling over 600 kilometers per second. That's 0.2% of the speed of light, which is it is an inconceivable velocity for pretty much anything that's not a particle. But for a big house-sized chunk of rock and ice, it's just truly insane that these objects are going that fast. Unfortunately, they're getting completely fried in the process, but it's really awesome that they're doing that. The comets in this movie that are flying around the sun and disappearing out of the movie again, they have survived past the sun. They're not getting completely vaporized by the intense solar radiation. Any comet that you see in this movie that does not have a label, it means it was discovered by SOHO. I really love that this mission that was designed to do something completely different, just by luck and by chance, has completely rewritten the history books, with more than well over half of all the comets that we have on official record now carry SOHO's name, and it was never even intended to do that. I just love that fact.
Well, it's time to say goodnight.
It is time to say
oh, look,
goodnight.
Maxi like disappeared. The vaccination got him.
Maxi evaporated.
He still has a Leo triplet in the background with his.
Yes. He's in another dimension. Where is Maxi?
Yes. Like
in another dimension. That's right.
Okay.
All right, guys. Good night.
Yeah. Good night.
Okay,
Have-
good night.
Take care. And good night to the audience.
You bet. Good night, everyone.
Bye-bye.
Oh, there he is.
Bye,
Bye,
Maxi.
Maxi. All right.
Good night.
Good night.
Okay,
Bye-bye.
bye, guys. Bye.
Bye.